and the fact that, did you get the surfaces made? If I look at these surfaces, I've got EG with boundary, brake line only, any of those, do you need to go back and recreate a usable existing ground that we can work with, or did you stay?
I, I was, I think I was pretty good about keeping up with you yesterday as far as generating each of those different services. I think I might have missed a few elements
Okay.
of some of those things, like the when we took the pre-established brake lines out, and we're kind of recreating the ones along that road right there where the contours in the road were kind of stepping down instead of going a constant grade along the face of curb, and where we tried to create our own brake line for that wall on the planned east side of the site. I think I got some of that, but
Yeah, so basically, and the only reason we did that as an exercise was, again, the data that you have delivered has the brake line, so you would not go through that given this situation. But if you're ever given the situation where this is all you're given, where you have these contours, you have to be able to control what happens here. So you have to draw the brake lines themselves.
yeah,
Or you have to take, let's say, these cyan colored lines. These are the edges of pavement. And over here is like, this is the actual curb lines. Now those are right now drawn 2D polylines. I'll go ahead and select a few more of them here. And our goal is to be able to make some 3D polylines out of those.
right.
We know that there is on the ground that those things are edges on the ground. So that's essentially, that's the rule of thumb when you're doing this kind of work, is that if it's an edge out there on the ground, it needs to be an edge in your data. So you would take these things and try to get them elevated. Now, some of things like this, the only thing you've got to elevate this stuff against would be, say, this contour line. So I know that this curb line back here is at that contour's elevation.
Right.
And this one is at that contour's elevation. And then we just assume a straight line change from there around to here and up to here and to here. And that probably doesn't happen that way.
Right.
Probably happens in a rather non-linear fashion, but it's not enough to kick out another contour in there. So, but again, if the only thing you have are contours, let's say you don't even have these 2D lines. Let's say we've got, how many of these things I can freeze at a time. So let's say instead of these retaining walls and edges of pavement, sometimes all we're given is something like this, especially if we're out in undeveloped land.
Right.
So that's where we need to know that we have to draw in those lines. Hopefully though, is when we're working with these outside firms that might be giving this to us, or if it's our survey department within our company, we're going to hope that they've created a brake line down those edges. And if we see contours like this, it's pretty well assured that they did. But if you see these contours coming up and then shooting across, cutting the gap and going back down, then it's probably a pretty good guess that they did not. So, if you got somebody else out there who was on the ground collecting the information, then that's where you really get the the locations of those brake lines. But if you don't have it, what are the techniques to create them? And the only thing we can do is just step down from the nose to nose to nose to nose. All right, and just basically put in that line that and do it as a polyline. Two choices, you can do it as a 3D polyline, in which case you have to, prompt for the elevation so that it can interpolate when you're clicking out into empty space and all of that. And you can also, type in A for arc and put in an arc in your 3D polyline, which is not really an arc, as we discussed earlier with the
Right.
segments. And then, but the easiest way to do that, or the easier way, is to go ahead and draw these in as 2Ds. And that way you've got that grip edit menu where you can change segments to arcs, and you can just grab the grip and move things around. And once they're moved, then we're going to go to our 3D data menu, and we need to elevate that. So 2D to 3D, and we do that by screen entities. And that's how we then lift what we drew in 2D up to 3D space, and it gets the elevations from everywhere it touches something, that it's crossing in plan view.
Right.
Or within that tolerance distance that we give it. And that's what sets those elevations. And then we go back and rebuild that surface with those included as break lines, and it will really refine those areas where we had, the stair steps along the edges of the roadway, and over here in this upper right hand area where this is really, a little retaining wall.
Yeah.
If I look at just those elements, I can see that that's what it's meant to be. But if all I do is grab that data and make it, tell it, hey, grab all this stuff and build a surface without putting any kind of break lines in there, then that's where it lets things from here look across and start building triangles across the gap. And that's where you get things like that big ski ramp. Why I call that a ski ramp, it's really more of a skateboard ramp, but anyway. So that's the idea. Now, what was I looking at? Here we go, yeah. I'm going to, let's see, match. There. Huh. They're not using a defined line type. That line type is defined as continuous. Yeah, it just depends on whatever software they use to do it with. So
Yeah.
you can convert that, but anyway, that's trivial. All right, so that was really the exercise there, so that you're aware of what can happen, what problems can come up, and how you can fix them.
Yep.
So let's go to the menu right down, thaw/on all layers.
Yep.
And let's turn off now everything except our break lines and our points to build the surface. So I'm going to go to view, and I'm going to say isolate layers. And again, you can use AutoCAD's layer isolation. Anything you're comfortable with is fine.
Yeah, that's going to be take some getting used to for sure, using some of the Carlson tools as opposed to the AutoCAD ones.
Yeah,
I guess mostly in regards to like how the 2D polyline interacts with but like, using the regular AutoCAD polyline command isn't going to give you that same
right.
functionality of being able to draw it through specific points and things like that.
Yeah, yeah, and that'll come along. You'll, once you know, particularly once you learn where those things are on the toolbar.
Yeah.
And I'll also recommend, if you haven't noticed in using it, there are certain commands, say like roundabouts and roadways, that the center line actually is drawn initially as a circle. Well, you need to turn that circle. It needs to actually be a polyline. So, it doesn't change the shape of it at all. It's just a polyline with a certain, it's got two arcs that have the identical radius. So that's how it works, but Carlson is going to be requesting polylines. So sometimes even lines won't work. You'll have to make them polylines.
Yeah.
As a result of that, over the years, as I've used this, I can't remember the last time I drew a line.
Yeah. I was instructed early on that, regular lines are, I won't say they're useless, but there's just so much more functionality with using polylines versus regular line segments
Right.
that I've just gotten used to doing polylines and almost prefer them over regular lines, since you can create a continuous curb line that wraps around a parking lot or something like that, instead of
Exactly.
about individual line segments or arc segments. And then, if you need to copy that into another drawing for something, or you're trying to move everything at once, you don't have to select 100 separate objects.
Yeah. Yeah, and I've got a really good friend that I've known for 25 years. He's a surveyor and he uses Carlson, but now he spent 20 years managing a surveying department for an engineering company. And then when he sort of retired from them, he went back out into solo practice and he got Carlson and learned to use it and all of that. So, but I cannot get him to quit doing lines. He'll just do a line because, a line is always 3D. It always has two endpoints and it has elevation on them. So he has trouble keeping track of a 2D polyline versus a 3D polyline. He can't quite grasp what's going on with those.
Yeah.
So to him, he just falls back in, well, I only have to think about one line instead of two different types of polylines. Well, okay. And he gets by and his work actually works, but then he sends me his drawings to work on for some other particular reason, maybe. And then, so I wind up having to convert them all to polylines and
Yeah.
all
And
that.
I get that, I guess from a survey standpoint, lines are better for them for stakeout purposes.
No, not really. Not necessarily. No.
You don't, because I figure, with a line, when you check the properties, you can see both the start and end coordinates, I guess, from a northing and easting standpoint.
You mean like like if you select it and you'll see,
right?
They show up like, starting X, starting, but I mean, you get those in polylines too. If I just do let me not prompt here. I'm going to go from, say, here to here. All right. So I've got those two. Now, if I select those, I've got this that I can do that.
Yeah.
Whereas I did a line.
And, in my opinion, it's just as easy for them to take, if they want it in lines instead of polylines, it's just as easy for them to take our line work in polyline and explode it or something.
Exactly. Yeah. Yeah. Yeah, so this one being a line, I see both of those coordinates at the same time, if that's what you're referring to. But then, and I see this delta X and delta Y. But, you know, to me, I've got this on my inquiry menu. I've got, let's say, turn on my drawing inspector. And I can see all kinds of things. There's my layer name, my horizontal distance, the slope distance, the elevation at the start, the elevation at the end, the slope at that segment, the ratio as a percent, as a ratio, a total distance of the entire polyline, and the current distance, that's of the segment that it is, and whether or not it's open. So if I walk this thing around, you see it's constantly reading out. You may notice those elevations and distances are all changing.
Yeah.
And I can, I've got all of these different things that I can display, and all I'm doing is hovering the mouse.
Yep.
So I don't, I don't have any problem not dealing, with that, the difference in the property reporting. I've got a different way around it. But again, that's something that's just, you're going to find yourself gravitating toward, or you're going to get really, really efficient at the old AutoCAD way of doing something. It's not to say that everything in Carlson is better.
No, yeah.
It's just, and particularly AutoCAD, as AutoCAD advances, they improve their product quite a bit. And a lot of it comes from their, oh, hey, we got people like Carlson over there writing their own commands because they're adding all this functionality and everybody seems to like it. So let's put it in there. I know, like, when you copy something, you can copy something to a different layer, all as part of the copy command now. Well, that didn't used to be as part of the CAD tool, but it was always part of Carlson's tool. Layer isolate, layer restore, all of those things, they came about because, I don't know if it was directly Carlson, but other third-party programs that wrote that kind of functionality, and Autodesk finally took notice. Now, there's one, for instance, that Carlson does called find a path on a surface. And for instance, if you can imagine, if you're building a, say a well pad, or a big high embankment, and you've got a nice 3-to-1 embankment slope that goes down and touches on the ground, but you're up there at the top. Well, you want to find, so you're looking down a 3-to-1 slope, right?
Yeah.
And you want to find the path from a certain point up at the top. What is the path down the face of that slope that is at, let's call it 5%? Find me that 5% line, and that's where I'm going to build my ditch, because I can't go any steeper, and I need to be at least 5% to make sure I drain everything or whatever. Now, in the case of a nice even 3-to-1 slope, finding the 5%, you can do it with Civil 3D, but you can't, what you have to do is you have to draw a line on there, drape it on the slope, and then check the slope and see what it is, see if it is 5% or not, and then you have to tweak it until you get it where you want it, over and over and over again.
Yeah.
But then extend that scenario to, let's say you're running a strip mining operation and you're out here in the middle of the woods out in 40,000 acres, and you're up on the side of a mountain, you're stripping coal off there, but you've got to haul that coal from where you're working across a valley and up to the hillside on the other side. But your trucks can only go a maximum of 8% before it's too steep for them to drive.
Yeah.
So you're sitting over there and you go, hey, show me the path that's 8% from here over to there, and it will go down and it'll find the path and walk up and draw it for you that goes down into the valley, winds around, such that it always maintains that 8% line. Then you use that as your design center line for your road, your haul road.
Sorry, Ken, are you are you looking at something specific for the example that you're relating right now? Or are you just
No, I'm just talking. Yeah,
okay? I wanted to make sure. I didn't see
sure.
anything on your screen. I thought I wanted to make
Yeah. I know it sounded like I was showing something, but yeah.
sure.
No, but anyway, so Carlson has always been able to do that. And that is, it's a 3D polyline and it's called, so 3D polyline by slope on surface. So you tell it, you tell it where you're going to start, you tell it what slope you're looking for, and you give it a surface name, and it just walks down all the triangles and puts all those together. It's sort of like flow tracking,
Okay.
except instead of
So
finding the maximum track, it finds a specific track. Okay. So it's a very, very useful function for engineers.
so it looks at the surface and just I guess creates 3D polylines anywhere it sees a run of a run where it is at that slope that you're specifying.
Yeah, I'll show you some examples once we get into some of this grading here in a minute. And I'll show you how that tool works and you can see it. So anyway, it's a very useful function, but in Civil 3D, you can't do that. You have to draw a line, check it, draw a line, drape it on the surface, check its slope, and it's too steep, it's not steep enough. And then you tweak the end and decide, well, what about doing this? Well, that works for, those little short straight runs, but the example of going down the valley and up the other side, well, that gets real tedious real quick.
Yeah, sure.
And so you ask, we've been asking Autodesk for years to put that into Civil 3D. And they just said, well, why would you ever need to do that? We decided as a programmer that you as an engineer don't ever need to do that. That's the level of arrogance that comes out of software.
It's pretty clear that they're selective about what they.
Yeah, well, it's their way or the highway. And
Yeah.
what happens is when they see customers leaving because other people are writing the tools that they should have written, that's when they start to write those tools. Now, I'm not
Yeah.
trying to beat up on Autodesk, okay?
Yeah.
That's by and far, has fueled this entire revolution of digital design.
Mhm.
But unfortunately, you can't get innovation out of them other than at the threat of losing customers. And that's the part where I sort of part company with them. But all of that being said, I think the whole thing started out by saying, it's okay to use an Autodesk tool, particularly because they do improve them. And a lot of times it's at the end of a gun, but they'll get them improved and then you can do those same things. So if isolating layers and storing layers, if you've already got that as part of your workflow, there's no need to necessarily switch to the Carlson tools. And I just am going to almost always show you the Carlson tools so that you're aware of them. And then you can decide whether you want to learn that, if there's enough additional benefit from doing that than there is from AutoCAD. And other people too, like, are you running yours on top of a Civil 3D installation?
No.
Okay, just plain AutoCAD.
Regular AutoCAD.
Yeah. So this will run on top of Civil 3D and AutoCAD map and all of that. And so when you do that, remember we talked about the curb and we did that 3D polyline offset, that offset 3D polyline.
Yep.
But in in Civil 3D, it's what they call it, a stepped offset or something.
Yeah, vertical offset.
Yeah, so you can use that tool, say, to work on the curbs here, even though you're running Carlson software. There's nothing that keeps you from using any of those other things. There's not, this is not to say that any of those tools are bad. It's just that, Carlson tries to mimic your workflow as an engineer or as a surveyor, or as a contractor, or as a Miner, whatever module that you're using, it tries to mimic those workflows
Yeah.
in more familiar terms. So, and they don't always succeed either. That's where they get things like exterior or perimeter polygon reduction for shrink wrapping.
Mhm.
But nowhere does it tell you what's going on. Nowhere do they tell you anywhere when you're doing that, that it creates that shrink wrap by triangulating the data and then looking at the outermost or peripheral triangles and then deciding how many of those to get rid of. Nowhere do they tell you that. You just have to talk to the programmers and figure it out, and that's what, oh, okay, well, now I see. But here's another prime example I'll show you really quick. If you do a join nearest, and you've got, join commands and polyedit, but you've got, you can type in a gap separation or pick it. But look right here, you've got, how do you connect it? So if you look at two, let's do two lines like this, and then I'm going to, all right, so now I've got two polylines. Now, if I say join nearest, and I'm going to show it to the gap so I know that I've got enough distance, so I already need it to be that big. But now here's my methods. I can either average the endpoints together, which will take those two endpoints and find the midpoint and put it right there. And if I do that, you can see that result is there. And, or I've got this one, directly connect the endpoints. Well, that's going to do exactly what that sounds like it's going to do. It connects them, right? But now here's where here's where when you hire, some Russian programmers to work on your team, the next method says fill it with radius 0. Well, we know what that means if we're, really thinking with our CAD brains. But some of the people that use Carlson software, they use Carlson software because they don't want to be CAD brain people.
Yeah.
They're survey people. Why not call that extend to intersection? That would be the better, more easily understood, project to intersection or extend to intersection. But they don't call it that. They suddenly slip up and put in program speak. So like I said, you'll hear me talk about how great it is. Carlson gives you these tools and stuff. Carlson screws them up too. So don't be fooled. We all, that's all going to happen. But anyway, moving ahead. So what we want to do is let's get us a good surface that we can work with, and we just need the one. And if you had one, I need to go back to put all the layers on, and I want to isolate now. So I'm going to isolate the 3D break lines, those random dots, these spot elevations, and I'm going to also get the building outlines. Okay. And that is on a layer called D building outline. I'm going to change that color just so that they're not so and not so confusing. I'm going to make them a sort of an aqua kind of. There we go. So now I can see those. All right, now this is really all of the three-dimensional information I need. I turned on the buildings outlines because I want to use them as my exclusion areas, right? Because I don't really know what's under the ground under those buildings.
Right.
And so a couple of things now is that we're going to build a surface. out of this information, and we are going to we're going to put some boundaries on it, so we can either draw our boundary manually, we can use shrink wrap entities, or we can let the program do the shrink wrapping for us. Now, the problem is when we do the shrink wrapping from as a program option right here, where we do not say use inclusion and exclusion, but we do say shrink wrap to perimeter reduction. Okay. When we have that and let the program do it for us, even though we can set it up and let it draw it, we are never prompted for these exclusion areas.
Right.
There's other ways we can do that after the fact later, but in any case, the easier way for me, the way I've always done is I like to draw that shrink wrap first so I can see it anyway. And I'll just draw it and put it on a layer called boundary. And I think while I'm here, I'm going to change that. Layer, I forget what I called it now. I guess it's just, it's not boundary. There was something else, topo. All right, we'll just call it boundary. I'll make it red, and I'll give it some line weight so I can see it. There we go. So now, so I'm going to shrink wrap my data here. I'm going to say across gaps, because remember that lets us shoot across these ends. We're going to put it on that layer that I just modified there called boundary. A maximum gap. So if you had something way too far, you could set that up. And my perimeter reduction, I'm just going to put it down here to medium. I don't want it to be quite so choppy necessarily. And I'll make it a 2D polyline. It doesn't matter. You can make it 3D if you want, but that's fine. 2D will work. So it's going to run. Now it asks me to select the objects. So I'll just grab all of my data. And there it is. And you can see I've got all this sort of choppy stuff out here, which is fine. We talked about ways to edit that, but I'm not working out here on the edges. So I don't really care how far out, and what happens in here to my surface. If I needed to see the surface out there for some way, I would do that. I would resolve that. Okay. Now, with that in place already, I'm going to build my surface. So I'm going to go back to surface, triangulate and contour, although I'm going to turn contouring off. I'll look at my selection tab, just make sure I'm not restricted to something here.
Okay, so you're taking the specify selection options off because you want to select just everything.
I wanted to look at everything that I select. Yeah, so there's no filtering on. Okay. And so then under triangulate, I'm going to write the triangulation file, hit select, and I'm just going to call it EG. Well, let's go ahead and spell it out. Existing grade. I've got all those others, with different conditions on them. So we'll just do it like this. And I'm going to check on to use the inclusion exclusion areas so that I can get those building outlines as part of my exclusions.
And leave it as trim edges at boundary.
Yes, because what this means is that when it gets rid of these triangles, it's going to actually cut them and heal them and make new
a new boundary.
If it crosses the boundary, yeah, it makes a new triangle and keeps it on the inside. If you say remove it, then it removes the entire triangle. So you get a lot of holes around the edges.
I see.
Okay. Yeah, so I don't really understand why. I don't know an instance of what would make that an advantage.
Right.
But anyway, so And I'm gonna leave my erase previous contours. I'll leave it on as all contour entities for now. I'm going to ignore zeros. No other check boxes there. Densify break lines. I'm going to leave that on generally as a matter of standard practice every
Okay.
2 feet.
So, touching on that, I was just curious if if is the interval being 10, is that I guess a default state?
No, that's just a number I typed in.
Okay.
I
Do you
yeah.
find it to be a pretty good
Yeah,
interval?
it depends. It depends on how dense your site is, or how quickly maybe the site changes. Like if you've got a lot of really quick changing elevation, a lot of quick relief changes, and like when you're going around the a curb return into a street intersection or a parking lot intersection, you might want that to be every 2 feet,
Right,
because you wait and go every 10 feet, you're going to maybe miss some little nuance in between there.
right. You're gonna end up with a straight line between the point of tangent and point of curve, and instead of something that follows along the face of that curve,
Uh,
right?
no, this density interval, this is how much distance along the features that you select does it drop a point. It's like adding a vertex every 10 feet.
Okay,
Yeah,
okay.
but it doesn't change the shape of anything. It just puts an extra point and allows a triangle corner to form at that point. Otherwise, I'll illustrate this here off to the side here in just a minute.
Sure.
But let's go ahead and get this one built first. So we're going to densify every 10 feet. Like I said, I just generally keep that in there together. I'm not using contours as source data, so I don't want to do any of the things in this little box here. And then it's not a big enough site for me to worry about having to simplify. So this is all what I need, okay? I'll say, okay. And now reading the prompts and reading the lines above, select the inclusion. So that's my outermost shrink wrap. So I've got that. It keeps asking me to select objects. I'm through selecting, so I'll hit enter. And now it says get the exclusions. So I'm going to get those building outlines. So I had that one, that one, that one, that one. Although I think this one is not. I'm going to shift select that. That's actually those, they're marked as ruins. I think it's just an old concrete pad.
Yeah.
But those 3, 4, and 5. There we go. Bump, 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 bump. Okay, so I'm through selecting those. I hit enter. And now it says select objects one more time, but the prompt is different to select the points and breakpoints to triangulate. So now I'll just grab all my stuff. And off it goes, comes up, there's my that head wall issue that I was telling you about that I'm not going to bother to fix right now. And I'm going to view 3D view surface file viewer. And there's my existing grade. Oops. I guess I gotta not hit cancel. And so when that comes up, I'm just going to do this to verify. Yeah, everything looks like I expect it to look. I've got nice smooth edges. There's my voids that I took out. Over there's my retaining wall edge. Same thing back here. Same thing right in here. And those are little loading docks is what they are. Actually, it's a truck stop area, truck stop job site. So that will be our design base that we're going to work with. Okay. Now, let's go over here and off to the side, and I want you to draw a rectangle. You can use AutoCAD's rectangle command if you wish. Anything's fine. something like that, okay? And, you know, of that relative size, I don't know what is that size. Let's see, my drawing inspector. That is 60 feet, so 60 by, that's 270, so 60, you know, something good enough.
So a quick question about the drawing inspector. Anytime I try and turn that on, it prompts me to select a surface.
Okay, what
Um,
happens is, are you looking at the drawing inspector or the surface inspector?
So I usually pull that off of the toolbar, off of
Which
the
is
inquiry toolbar,
off of which one?
the inquiry toolbar. So I
Okay,
think it's at the top right of your toolbars. Yeah.
down
So
right,
the
okay.
button- that's the button that I click, but oh, hang on now. Okay, well,
Well, there's another icon that looks close to that. You see that looks like a secret agent kind of guy.
yeah.
If you look over here at this one, it also looks like a secret agent kind of guy. Slightly different, but that is the surface inspector. And when I do that, this is what comes up. It asks me to pick surfaces.
Okay.
Is
So
that,
no, so I'm choosing the drawing inspector, but I guess like um I guess it only brings up the Carlson surface selection menu the first time I do it, because now that I'm clicking it, it just turns it off and on. It doesn't prompt me again for the to choose a surface. So
yeah, well, I'm not sure why it should ever prompt you for that surface though, is the problem. Because none of these things are surface dependent. Even elevation, it's not looking for surface elevation, it's looking for entity elevation. So
right.
that's the difference in this, the two commands, because the surface inspector reads triangles. It doesn't read drawing objects. But
Gotcha.
anyway,
Anyway,
I don't know. Keep your eye on that.
yep.
So, all right. So let's take a look at this right here. This is a rectangle, 2D polyline. So we're going to assign some elevations in this. We're going to turn this into a 3D entity, and we're going to do it much like we did that the parking lot deal. Okay. So remember with the building, and then we had the parking lot went down 3% here and 1% here. And so I'm going to show you what this densification does.
Yeah.
So when we have something like this, it's got 4 points. We need to assign some elevations at those corners. So I'm going to go to my 3D data menu, and I'm going to choose Polyline Elevation Editor. I'll choose that polyline. And now I'm going to get this little dockable function over here. And I've got, here's point number 1, number 2, number 3, number 4, and then back to 5 again. So 1 and 5 are certainly are not, well, let's see, number 2. Let's say 2.
Sorry, which button brought up this menu?
Under 3D data, polyline elevation editor. Yeah,
Thank you.
sure. All right, so we're going to say, sit here on this first one, and we'll lock it down and call that a control point. And we're going to give it an elevation of, let's just call it 100, okay? Now, number 2 to go to number 2, which is out here, I'm going to go at, say, let's go as a 3% slope. So I was typing right here, I typed down in this slope field 3, go 3%, okay?
Yep.
And
Then it looks like it interpolates the rest of the way until you give it a.
exactly right. And so now I'm going to say, and I'm going to lock number 5 as well, because 100, 100, it's really the same point. All right, so I went 3% there. And I go to uh, 0.4, but I need to set this point back here. Okay, so I don't know what this slope coming down here is, but I need to set point number 3. Well, I can't set it backwards directly with this editor. What I'm going to do is come up here and temporarily reverse the direction of the polyline. So I can always, I can only set the point ahead of the point I'm sitting on.
Okay, so I guess just in terms of workflow, it's important to remember what direction your polyline is going in, because like you just said, you can't work backwards, essentially.
Yeah, I mean, you don't have to remember it, because this will always show you, because you see how it's numbered things 1, 2, and if I just step through them, I can see, you can see the little highlight
Right.
working. So if I'm here, so now I'm going to reverse it. Now these things stayed like they were, but now if I look at, there's 1, and then 2 is going to be down here, and that, instead of being 102.12, that's the one I want to be 100 as well. So I'll lock that down and maybe just call it a 0 slope. Okay, so I'm at 100 to 100. So 1 went to 4 at a 3%. Now I'm going to go to 2, and I see 3 is the immediate ahead of it. So if I go to 3 and set that at 1%, so I'm sitting there at 100, 100, so it's flat. And then I go 1% to that, and then it goes up to 4 from 3 at 1.41%. And then you see it goes back to 100 at a -3%. Okay, so that's what we originally set when we had it turned around the other direction. And you can reverse it again, it doesn't matter. All right, so I've got some differing elevations here that I want to see.
If you were to before we reverse the direction of this, would it have mattered? I mean, couldn't we we well, okay, I guess it depends on what we're trying to accomplish. Never mind. Forget I.
No, go ahead and think it out, think it through, because it might open up an insight for you. What?
I guess I was just curious if it would have mattered. I mean, I guess we could have, having it the original direction where 4 was in the bottom left corner of the rectangle, we would have set that at 100 after setting the slope of line 1 to 2 to 3%. But then I guess we still, 3 would have stayed at 100 as it originally was, and we wouldn't have.
Yeah, well, it was originally 0, but it would compute it as coming from 2 to 4. It computes it as it interpolates it.
Right. Okay.
If I uncheck this, that's what allows that to interpolate through those points. So I can check, and it doesn't have to be a rectangle, it'll be any shape. And I can say, well, I don't want to lock that point and lock that point, and lock this point and lock this point, but everything else I want to float in between. So I just check these on, and let them go.
And since this only works in one direction, then we couldn't have like gone into point number 4, for example. And right now it's reading as -1%. We can't go backwards and change that to +1%. That would have changed the value of point number 3.
Well, no, if we do anything here on number 4, on line 4, if we change that percentage here,
Yeah,
that's going to affect the next point.
okay, because it only works in one direction.
It only works forward. Yeah, it only sets you are sitting at whatever line you're on, whether it's locked as a control or not.
Okay,
If you're sitting at that point and then you go to type in, if you type in an elevation, that affects the point you're sitting on. But if you type in a slope, it's the slope away from this point to the next point down the line.
sequentially, okay.
Yeah, and that's why I had to reverse the,
Because that kind of allows you to go backwards in a sense. Well, it's going forwards in the opposite direction.
right.
Yeah.
So
you just need to be conscious of what direction you're currently working in, if you need, depending on what points or lines you need to change.
yeah, so I'm looking at something here. I've got, well, there's an overlap because 1 and 5 are the same points. All right, so 1
Goes up 3% to point number 2.
yeah, so that actually this is, I got it backwards. It goes 3%. This percentage is the incoming slope from the preceding point. Okay. I said it was only it's the percentage, it's the slope to the next occurring.
Yes, that I see what you're saying.
Yeah, it's not, I had it 1 point off. It's the incoming slope. It's what sets this elevation. So then that one, so 2 is raised up 3%. Okay.
Right.
And then 3 goes down to, 3 is away from 2. Is if I calculated from 2 to 3, that would have been a 1.41%. But I didn't know what that number was. So I left it alone.
Right.
Reversed it, went back to 4. I had it hard coded at 100. And I said, we'll go up at 1%. And that's why then when I reverse it again, it comes back as a -1% from into 0.4. So 3 to 4 instead of 4 to 3. That's why 3 to 4 is -1%. All right. So I'm high up here. Well, anyway, I'm not really, so I'm going to go ahead and say, okay, I'm not really trying to replicate that parking lot. I just want to show you what happens when you,
Sure. That's fine.
for the densification, okay?
Yep.
So here I am now in my 3D viewer, and I can see there's a little bit of a twist on it there. Okay. So let's do a triangulate and contour. And this time I'm not going to write any triangulation file. I'm going to uncheck that. I'll go ahead and draw these contours at say a 1/2 foot, just so you can see them as we're working. No labels. Triangulate, and I'm going to uncheck the inclusion. I'm going to shrink wrap none because it's all square. It won't have anything to worry about. And let's turn this one. That's fine. Ignore 0, and I'm going to uncheck this densify break lines. Now, what I want to do too is I want to draw the triangulation lines. And so they're going to be on this tri-lines layer. I'll go back and change the color of it later. But I want you to see the triangles that result when we do this. So when I do that and I say, okay, and I'm going to pick this guy. So you see there's that parking lot issue with that crease down the middle because only two, I've got 4 points
Right.
along. So no other triangle corner could be found anywhere, and it's always going to do this. Now, I will erase by layer, select from screen. I'll get one of those, and one of those. Now they're back to this was again. So we're going to repeat that process. Triangulate and contour, and this time we're going to densify. We'll do it as let's say 35 feet. Select this, and now you see where the triangle's formed. And if you measure that distance from here to here, you see down here it's 35 feet. So it went along all of the data items that I had, and it dropped a point every 35 feet. Okay. If I'm going to erase by layer again and just hit OK because it's the same layers. If I repeat that same deal, and yet if I have instead of 35, let's say I have it as 5 feet. Well, I get them real close together. But now notice, you see, you still are getting that stair-steppy looking thing in here that a lot of people are going to edit by saying swap triangle edges.
Mhm.
So what we want to do, oops, sorry.
What did you set the interval to? Like 5?
5 feet on that one. So you see they're real close together all around the edges, but there's nothing in the middle yet.
Right.
Okay. So what I normally find is a good mix, because that makes a lot of them, is, 10 feet is generally enough to pick up the features I want. And it depends on my job site, and you'll get to know it a little better. So there's my 10 feet. I still have some things, and sometimes, Jacob, honestly, this is going to be okay. These jaggy contours, and you might even, just fix it graphically and smooth it out and hand it to somebody, because they're not necessarily, doing a whole lot with this. But in this regard, because if you've got the opportunity to make it better, it's always good to do it. But you have to know what it is you're trying to do. So if I'm modeling, half the county as a watershed study, I don't care about this. I don't care about, whether I've got a wedge curb versus a square curb, because I'm looking at overall trends in a watershed. So I wouldn't waste any time to fix stuff like this. But if I'm doing a nice site design for a sheets store that's going to go in, I want it to look nice, and I want it to be able to be built well. So to show you what I did with that textbook example that I showed you the other day, I just drew a 2D polyline, and I went from, say, this corner to that corner, and I took that and just moved it up, 10 feet. I went from here at 10,0. Oops. At 0,10, he meant to say. All right, so there's that one. And then I would just array that. Here, and we do a rectangular. So I want to say, can I type a number? I guess so. Yeah, okay. And now count. These are columns. Don't need that. Let's see. Try that to 1. All right. Number of rows. Let's make that 25. Make it 26. All right, so there we go. Now, I've got a bunch of things. I'm going to explode that because it's I need to get to the polylines. All right, so they're there and they are simple 2D polylines. So I'm going to drape them on that figure. So my 2D to 3D by screen entity, I will, that's all good. It's okay. I'm going to select the ones I want to convert. I'm now going to select the polyline, that the rectangle that we set the corners on. And it says it converted 26 polylines from 2 intersections. So if I take that and look at that in my 3D viewer, I see that indeed I have laid that out. If I can give you a little bit of a vertical exaggeration, so now you can see that in fact that's what's happened. But now, even though I've done that, if I do that triangulate and polyline, and let's say I don't densify my polylines, even though I have all of those things out there, the only points it can see are the endpoints of those cross pieces. So that's what looked like in the middle of that article. That's why you got all those stair-steppy things, because and you can see the triangles are only edge to edge. There's nothing going this way. It's just edge to edge. And you know, you can see them there, and they're not, again, not part of what I'm trying to do with it. So I could do this. I could say, densify my polyline vertices. I'll just do 1 to show you. Give it an interval of 10. And so now there are the points that triangles can form on. And that would be, you know, before that they had that switch in the triangulate and contour command, we used to have to go through here and manually do that. Well,
what button was that in the triangle?
goes under the edit menu, polyline utilities, densify polyline vertices. There's also reduce. And
Okay.
that's also up here on the polyline toolbar. You can see here's reduce and there's densify.
Did you select everything or just the polylines inside the boundary?
I just did the 1.
Oh, just the one. Okay. Just the
Yeah, I'm showing you the difference between if you manually densify. See, if I did not densify this, it still only has 4 vertices.
right.
I did not densify any of these. They each only have 2 vertices.
Okay.
But this one now has all these vertices. So you can imagine before that switch was in the command, we used to have to do this manually. It really started to hog up your drawing. Your drawings would get very large because it has to store all of that vertex information. Okay, so I'm going to reduce the polyline vertices so it can now take them back out. It's now back to 2. Okay, I just wanted to show you what happens. But now, because the switch is in the command, I go back to triangulate and contour, and I'm going to turn on densify break lines with that 10-foot interval. What this does is it, in memory only, densifies all of the data we select, builds the triangles on that densified grid of vertices, if you will, but then throws them away. It doesn't store them as part of the drawing. Okay. So if I do that and see this, look at the resulting triangles. And of course, the resulting contours are much smoother, but you can see this triangle goes, let me, select, where's my, there you go, select similar, and there's the back on it. There you go. So you see the triangles now, instead of just going edge to edge, real skinny triangles long back and forth without a chance to change, they're smaller. You see how they're formed like this? So they're much closer together, and that's what helps define those contours and make them smoother as it goes across this warped surface. So now, that being said, if you look at, say, in relation to this, remember when it had 10-foot vertices all along its length? That was where the triangles could form. Here, here, and here. Okay, so now what it did was it densified everything I selected, all of those yellow lines and the square around it, and it put points down every 10 feet so that triangles could form there, therefore smoothing out my surface because I've got smaller, more localized triangles and they're all, closer together. And then it threw the points away. It didn't need to keep the points anymore as part of the drawing. So that is what that is what this switch means, to densify the break lines. Now, and use it judiciously. When you use it here, it's going to make your surface more complex. It's going to give you more triangles potentially, but it won't affect the things in the drawing. So I wouldn't suggest necessarily that you always use it. Just, evaluate what it is you're trying to do. Like if you're doing a borrow pit or a pond bottom or something, and if it's flat, well, you only need those two triangles like you would have gotten had you only done this. And let's say no densifying. If that's a pond bottom and it's flat, then I've only got two triangles as part of the surface, and that's all I need.
Yeah.
So use your mind as to what it is you're trying to do, and if you need to make that, a smoother transition. So if I see this surface, where did I put my surface right there? And oh, well, I didn't save it. Never mind. That's the whole point, because I've only got I've got this as, it's too slight. I need to do this. There we go. There's a 3-time vertical exaggeration. So you see the triangle there's a ridge line in the triangles that have formed, and you see the white line, that's the contour as it crosses. But look, as I swing that up, you can see these yellow lines are really underneath where that white line is.
Right.
Okay, and that's what all of these yellow lines were. That was just my means of densifying this data structure. Okay, so anyway, that's what it is. I want you to get an internal sense of that as to what it does, and to realize you don't have to densify your polygon vertices. You can let the command do it for you. there are other times when you might want those vertices in a particular drawn structure. So of course, densify it and leave the points in there, but just don't, you don't want to take 30,000 acres worth of coal reserve property and densify everything that you run across. You're going to make a really massively huge file that you're not going to be able to work with. So,
Yeah.
all right.
All right.
That is that we now have a design base that we can work with. And so let's go back to, let's turn on all of our layers. So I'm going to go to view, thaw/on all layers. And I'm going to go back to view and I'm going to freeze layer by pick, and I'm going to freeze off the white break lines. I even freeze off the boundary layer. I don't need that anymore. I'm going to freeze off these pink magenta spots. So this is really more like what I'm used to seeing. I'm used to working with this as a design base. Hey, here's my existing ground. Let's design something on top of it. All right.
Yep.
So the simplest thing, you've already been doing some of that. You've been drawing things and then converting them to 2D, from 2D to 3D by screen entities. But now we have a surface that we can do that with. So let's say we're going to put well, I see from here to here, or even across here, I've got, storm inlets running down the road, for instance. And if I were doing that to make, say, a storm line, well, of course, it's not a good example, because the slope of that is more to have it flow than it is to keep it a constant buried depth. If you're a water line, that'd be a different story. So let's say if I'm going to, I need to bring a water line across, across part of this over here. Say from this building, I've got a water main out here or something. I need to go into this building. So I'm just going to draw a 2D polyline again. And I don't care what layer I'm on. I'm going to just come over here and grab it from the edge of the road. And I'll come over here and grab, say you're in the midpoint of my building. Right. So that's going to represent my water line coming into my building. Yes, I know, there are all kinds of different things, and I'm going to come in perpendicular and all that. However, I've just drawn a 2D polyline. So if you want to put that on that surface, there's several ways to do that. We can, again, we've got these drawn entities, the contours, and even if we turned on the break lines, we would see those, but we don't even need to have those on there. We can, now that we have a surface, we can do a 2D to 3D by surface model. Okay. And we're going to use that existing grade, say okay, or open. Now it wants us to select the object. That's the one or ones that we want to change. So I'm going to select that object and hit enter. And now you should get something like this. I don't know if yours is exactly the same, being a couple of versions back, but it should look like this. And here's our choices. We can add vertices at grade breaks. And what happens when we do that is it puts this on the surface, and every triangle edge that it crosses of that surface, it puts a vertex in this line. So this resulting polyline will mirror the surface exactly. Okay. if we do not do that, it only puts the vertices of the line we are converting on the surface. In fact, let me fix this a little bit better. I will add a vertex here. Let's move like this so that you can see I'll have more than one. Let's do that. It's not gonna snap exactly the way I want it. Anyway. All right, so that might be, the reality of my water line. Okay. So if I do a 2D to 3D by surface model and choose my existing grade, select my object. Now, if I say add vertices at grade breaks, I'm going to also keep the existing, and I'm going to give it a -4 feet to get it under frost depth here in Western PA. And I'm going to put this on 3D waterline, we'll call it. All right. So now what happens, or what got created there, was if I view that, you see now I'm rolling it up on the edge. So everywhere it crossed, let me give it better. Let's zoom. Let's view the surface. And let's turn the contours off and the triangles on. And then let's add this and turn this off. There we go. So now you can see it was draped across every one of those triangles, and everywhere it hit a triangle edge, it made a point, and then it was lowered 4 feet. Now let me, my vertical scale is back to 1. All right. Question?
Would you mind stepping back through how you added the draped polyline into the surface viewer?
Oh yeah, sure. We're going to do the surface, and there's two approaches here. You can do the 3D viewer, select your stuff, and then add a surface to it. But you can't. I don't think. Let me try something real quick. If I select that, and then I add the surface. Well, I guess you can still see the triangles. That was all right. So that's one way of doing that. There, you can do it one way or the other. You can do it from, I did the 3D viewer window, I selected my polyline, and then I added the surface.
Yeah.
Or what I did the first time is I did the surface viewer and I loaded up the surface first. And that gives me a little more control over showing contours and that sort of stuff.
Right.
And then on the model tab, which is where I went the last time to add a surface.
Yes.
I'm going to add entities. You see this second button right there? And I think,
I see. Okay.
yeah, I'm trying to, I don't,
You can't right click polylines and add the same way that you can a surface.
that is correct. I was just noticing that, but if you double click it, no. Yeah, so I had to do it from that button apparently. All right.
Okay.
So now that grabs that. All right. So that's what happened is that it draped it on the surface. Go back to illustrate this again a little better. I'm not going to give it that -4 foot. I want to show you, I'm going to say 0 vertical offset. All right, now. So there you should be able to see everywhere it hit a triangle, it put a vertex in my line. I draped it right on the surface, see? Now the other option, which is really what you would be doing instead of that, is to uncheck that. I mean, you do that when you need to do that, but you don't do that for a water line because you don't want to have to put all those twists and turns in a water line.
Yep.
So you would uncheck that part. And we'll just leave it here. And so when that happens, we're going to wind up with a situation like this. Where the vertices of my yellow line, you see, it took the one endpoint, and you can see, that endpoint was touched onto the ground. Of course, the concluding point was touched onto the ground, but also the point in between. Any vertex along my feature
Is just wherever that vertex touches the surface.
exactly right. And so in that regard, you would then, let's say you went across a part of a surface model and it had a swale in it or something. So you would need to make sure that you get below that swale in terms of frost depth, things like that. So, none of this stuff has an easy button that says you're allowed to quit thinking. You have to always think and think like an engineer. So if I'm coming across here, with that water line, I may be, 6 feet deep in here because I have to get underneath the bottom of the ditch over here.
Right.
All right, so it's pretty simple stuff, but that's the way you use those tools to do that with. Okay. So that's essentially draping onto that surface. That's sort of the start of what we're going to be doing design wise.
Sure.
So we've got a couple of things. You can draw things. You can draw, say this building, and that's at a 0 elevation. But if you needed to put that building in and give it a finished floor elevation or whatever, you would drape it on the surface, maybe raise it up or down enough of an adjustment to come well with what you wanted. If you are designing, let's design let's see, we've got, this comes up, this is a little raised cemetery up here, parking lot down here. Let's put we could do this in terms of Let's draw a little, we're gonna draw a pad in here. We're gonna essentially draw a little pond or a borrow pit or something like that. We're gonna cut down into this flat hillside, okay? So I'm just gonna draw a standard old rectangle right in here, about like so. All right, now that's, again, just a 2D polyline. Now I can drape that on the surface, or in the case of what I'm trying to do, I'm going to really, I want to make that a constant elevation, perhaps. You see, this is 1315, about the midpoint. So there's 1310 and a half, and it comes up to 1317, right in there, 18. So if I make this, if I want it to all be cut here, let's see, let's make it almost like a walk-in edge. So I'm going to just simply select that and go over to my properties. I'm going to give it an elevation of 1310.5. You see something here. So I must have snapped onto the corner. That's what gave it an initial elevation. All right, so I'm at 1310 and a half. That's where I'm going to walk into this flat pier, but it's flat all the way back. Okay.
Okay.
Now, how do I get from this? Whereas, you know, yay me, I've got a surface and I've got, you know, a floor. How do I get that floor to tie up into my existing ground? And there's a number of ways to do that. The way you're going to wind up doing it most of the time is with design pad template, because it gives you so much control over things. But sometimes you do it edge by edge. I did that little carriage house development up in Buffalo I was telling you about, next to the Buffalo Bills stadium property. And they had all these little retaining walls at the bottoms of their properties, right now, that real sensitive area. And so, you know, I was constantly, you know, drawing a line, draping it on the ground, and then projecting it up, getting the top of that wall. And so I would do that, you know, for 40 some different properties. I didn't use design pad template there. I did it with this method I'm going to show you here right now. And that is, you know, basically projecting this item to the target of the slope. Okay.
Right.
So now that we know where it is and what it is, we're at a certain elevation. We're at 1310 and a half. So we're going to be climbing out of the hole. So we're going to be projecting to the outside. I think, you know, we have an inherent sense of that. So we'll come up there and we'll keep this sort of job going here, this role or this little task going, and we'll do it several different methods. And you'll see what happens when we get into the design pad template, okay? But for now, it being 10:30, good, it's our mid-morning break. Let's come back at, say, 10:40.
Okay.
Is 10 minutes enough of a break for you? Do you need more, like 15 or?
No, that's fine.
Okay.
Yeah.
All right, well, I'll stop this and pause the recording. Well, so now, all right, so we have a figure. It is a drawn polyline. And it has a particular elevation. Now, how do we offset, you know, where do we find out where the edge of this coming up at a particular slope, how do we find out where that lies on the ground? And of course, if it were, if it were a, say that was the outline of a building and you were putting a basement in it, you want your walls would be nearly vertical coming out of the ground, okay? But we're going to put nice 3-to-1 side slopes on this so you can see them. And so we're going to do that with that offset 3D polyline. Even though our polyline is only 2D,
Right.
we need to offset it, but it's going to be a variable distance horizontally, well, vertically as well.
Depending on where it is relative to everything else.
Yeah, so we're going to offset this at a particular slope upward in this case. And we don't have to know that it's upward. We just have to know which side to go, and it will go either up or down until it hits that target surface. So, so we're going to use that offset 3D, which is on my polyline toolbar. And of the different methods, interval, variable, multiple, constant, surface, or intersection. Here's a real quick rundown. I think the help system has a little sketch of, well, I thought it had each one of the things, but I guess not. But anyway, shows you a couple things of what it can do. The interval method, and that's how we did the curve yesterday, was one horizontal, one vertical, all the way along the polyline.
Yep.
The constant has a horizontal offset of whatever given distance you tell it, and then it sets the elevation to one constant elevation.
Like if you're creating a building pad or a basement or.
Yeah, exactly.
Something like that.
And variable will allow you to specify each offset individually, side by side. And here you can see you build a little table. And then the surface method, we're going to offset or project a polyline onto a surface based on cut and fill ratios. Okay, so that's what we're going to do, is we're going to go to a surface. And we'll say, okay. And around the exterior corners means when it goes out here, it's going to project each edge up, this edge up, this edge up, and this edge up. But there's a place in the corner where this edge being projected comes straight up like this.
Right.
This one comes straight up like this. And so if you say round the corners, it's going to go out to that outermost point and this outermost point, and it's going to radius that in. If you don't round it, it's going to go in a sharp point. Okay.
Yep.
It's so we'll go ahead and say, yes, I'll round the corners. What slope format do I want? I want to use ratio. And here's the polyline I'm going to offset. There's my target surface. And it wants to know if I'm in a case of fill, what slope do I want? I'm going to just stick with 3-to-1. Same thing for cut. And now which side? Well, I'm going to come up from the bottom. I'm going out to the outside. So I'm going to look like that. So as you can see, now it says pick another, so you can keep doing it multiple polylines if you want. So right here in the middle at 1310.5 is what I've set mine to. It's right on the surface right there, so it didn't have to go anywhere. Everything else, it brought up and out, and you can see that. And basically that outer line is the daylight line of our little pad, right?
Yep.
And so we could then take that and that, make a surface out of it, and then merge that into this surface and get a final composite surface if we want. All right, so there's nothing wrong with doing that. You can always use that as an offset, but now what happens is, I would need to make sure I turn on my densification because I want triangles to come across like this. I don't want long skinny triangles just from these four corners only.
Right.
All right, now that being said, and this is a way to do that, just individual line work. And I do this quite often. Well, not so much to the surface. I'll do the interval for like curves and stuff. But if that same concept, I have to do some manual additional work here. So let me erase this one, and let's set this to be, say, 13, 14. So it's close to even cut and fill. And then if I do that same offset to surface, yeah, ratio. Let's see, pick the polyline, pick the surface, 3:1, 3:1, pick the side. So now I've got where half is in fill and half is in cut, which you can see like that. Okay. And again, that's the daylight line. That's where 3:1 slopes intersect that original ground. And the backside I'm in cut, and the front side I'm in fill. Okay. So what we can do along those lines here separately from that is a tool called Design Pad Template. And what this is going to do is basically a lot of the things that I would be doing manually after I did it with this 3D offset command. And if I wanted to visualize the geometry, I might draw the little cross lines in between those two outlines, much like I arrayed those lines across the parking lot. So if we choose Design Pad Template, notice there's all kinds of things, and we're going to run through this pretty fast right at first. We'll get more into this as we go along. But we're going to say our target is our surface file. Notice you can offset anything up to a particular elevation that would be like constant in the 3D offset. So we could have done that with this as well. But we're going to choose a surface file. We're going to go to the outside. If it's closed, notice it says from closed pad.
Right.
Pads don't have to be closed. They can be linear features, and you can offset them one side or the other.
Yep.
Even though it says design pad. All right, so we're going to go to the outside. We're going to use ratio. I'm not going to do any of these except round the corners, and I'm going to draw the side slope polylines, and that's the part I wanted to show you about. I really like this, and the color. We're going to turn on the color. I'm going to also erase any previous pad entities for right now.
Is there a difference between the slope projection perpendicular to pad polyline versus slope direction?
Yeah, there is. And we almost always want to keep it as a slope direction. That's the more conservative. But what that means is, let me see if I can sketch you out an example of that. I'm going to draw something here. And we'll say we're looking at this in profile. And I've got, you know, say my ground goes from, you know, down here's my original ground, and it looks something like that. Okay. So if this were a case of, let me see if I can figure out how to show this. Oops. All right, so here's a little ramp that we constructed, right?
Is this like an isometric view?
Yes.
Okay.
And I'll make these. And so let's say the contours are going to go something like this. And I'll just copy from there to here to here. Here and to here. And then we, you know, this contour went around here. And then of course they wrap around the backside as well. Okay.
Right.
Now, if this plane of the ramp were what we projected, and it wound up building a surface like this at 3:1 coming down down this edge, you know,
Yeah.
to the existing ground. If we say perpendicular to the polyline, that means that our 3:1 is going to be nothing there, arrow. Oh, arrow size. Let's make it 5. That. Okay. So that would be perpendicular to the polyline. That would be a 3:1. But we turn our drawing into the local planning commission, and they've got a new kid there with a scale and a calculator, and he starts measuring the slopes, and he's going to measure this direction, right?
Right.
And that, you see, the interval between the contour lines is smaller than it is here.
Right.
So that means that would be less than a 3-to-1. He would send it back and say, nope, you violated our minimum slopes, so I'm not going to approve it. So if we say calculate it perpendicular to the slope direction, that would guarantee that this slope down here would be 3-to-1 along the projection of the slope, not from the polyline.
I see.
Okay. Wow. I'm not much of an artist. I apologize. Anyway, so
Hey, Ken,
back, yeah.
just real quick, I meant to ask this as soon as we got back from the break. Would it be possible to push the lunch break off until 1?
Oh, sure. Yeah.
Okay, because I've got a committee here in-house in our company that I didn't realize we were having a meeting today, so.
No problem. As long as they bring pizza for you, I'm happy with it.
Yeah, but yeah, it's just from 1 to 2 and may not even last that long, so.
Yeah, no problem at all.
Okay.
Okay.
Yep.
All right. So now, so you can't do that in the class with 8 people in it. So in that case, you've got a really good deal on being the only one in class. So, yeah. All right. So our design pad template.
So yeah, slope direction outside.
Okay. So slope is going to almost always be kept to that because that will keep you more conservative. Okay. But there's times when you might want to do it from the polyline. You just have to evaluate what you're doing here.
I guess it depends on if you have like a really nice even situation and
Oh yeah.
the pad direction and the slope direction happen to be the same, so there's no issues with
Yeah, there's no real trade-off. Or
right.
you can also, I mean, we're offsetting something that is planar, it's level, and so it's going to essentially be the same thing.
Right.
In this case, but that could be an inclined slope that we're projecting. It doesn't have to be level. We could even take that, that daylight line that we generated earlier, we can offset that the same way.
Right.
We go up to a height and then offset that down to the surface. So they're not necessarily always even, but in this case there are. But now notice a couple of the options here that we can get. There's this one that says use a slope pad design, and that lets you do things like you give it an elevation, and then if you turn that on, it's going to then prompt you to show it the slope. So you can say, I want to slope from this corner down to this corner at -2%. So I can drain down to that corner, and it will take care of setting the elevations all the way around there such that it goes 2% down that direction. Just like we did with that editor a little while ago, but it does all that stuff for us automatically. Okay,
Yeah.
so we've got a lot of options here. We can calculate earthwork volumes between the resulting surface and our target. We can calculate the pad as a surface, so it does it all in one step. But what I like to do is to get, because what this command ultimately does is it draws the geometry. It draws all the 3D edges and such of what that should look like. And then we're going to isolate those and build that into a surface. And then we can compare the two surfaces for earthwork. We can merge one into the other, that kind of thing. Okay.
Yeah.
So for now, let's just see what happens when we draw this. I will erase previous so that we can do this multiple times if we need to. I'm going to set my polyline spacing. Let's just put it at 10 right now. And you'll see what I mean. That's the side polylines. Those are those little lines that it projects up between the two outlines.
Okay.
And this corner delta angle, that is that rounded corner. That means, all right, I'm going to draw those lines perpendicular to my pad. I get to here and I stop. I'm perpendicular to the pad here. Well, now I need to take this last one and swing it through that arc. Yep. Holding that corner. And that's the delta angle, is how many degrees do I swing each one.
Okay.
And 10's a good number. Shrink and swell, you know how that works. And you have subgrades and topsoil, all kinds of things that you can do with this. You can say trim existing contours inside the pad. If you said no, then it would trim out these drawn contours, except these are not our generated contours. These are just lines from the other file. If we had drawn our contours, we could do that. All right, so we're going to do that, and I'm going to come down here on our pad layer, and I'm just going to call that pad. And we'll say, okay. And now it wants me to pick the pad polyline. Now, and then pick the target surface. And now, because that polyline was at a specific elevation, it's going to use that and come up with these slopes. I'll go 3 to 1 and 3 to 1. If that polyline was at 0 elevation, it would tell you the range of the existing ground underneath that polyline. And, you know, it goes from this low spot to this high spot, and you figure out where you want to set it. And we just sort of arbitrarily set it to this 13, 14.
Right.
There you can see the 0 line, and the blue lines are fill, the red lines are cut. And those are those side polylines, and there's that 10-foot separation. Okay. So then if we isolate, sorry, hit the wrong button here. Let's see if we isolate the pad layer, you know, we can see what that looks like. And that gives us a lot nicer way with these sidelines in here, which are not totally necessary. I wouldn't have to have done those. I could have only done the offset, which would give me the outside, and densified, and I could have built the surface that took care of that in that regard. Okay. Plus the fact that this outside line is a closed polyline, so that becomes automatically my inclusion polyline, so I don't get triangles across these inset areas.
Right.
Okay. So that's there. Now it also asked me if I needed to adjust. I could have adjusted. I'm going to restore my layers. But with civil, now you have this same command in survey, design pad template, but you don't have edit pad template. And here's what's nice about that. You just pick something that's drawn there. You get this little thing up, and it tells you the pad, so you can change that. Let's put that back down to say 13, 10 and a half, if we had it originally. And then we're going to hit the process button, and it will redraw that. If we had that at 1305, it's all in cut. If we had it at 1325, it should all be in fill. Yep, it is. So you can do all of these different kinds of things. We'll put it back to 1314. And you can.
It changes the pad elevation, right? It's, I mean, I can see in that menu, it's not changing the actual, like the cut and fill slopes.
No, but you can do that here. Let's say if cut, I'm okay with 3 to 1, but my fill is pretty sloppy, so I'm going to make that, you know, 4.5 to 1. And so that pushes this out, but keeps this back here at 3 to 1. And makes that 4.5 to 1. Okay. You can also do things like with these given things, you can move the pad. All right, so it's pick a start point. So I'm just going to take it from here, slide it over here, hit process again, and it recomputes. Okay. Oh, move it back here a little bit. Bring it back into here, process. So there's closer to where I originally was. Now, you've also got, if you look up here, there's 1160 yards of cut, 1214 yards of fill, although it says no volume right now. But if I say report, for instance, I can get there's my 1160 yards of cut, my 1214 yards of fill. And then I could say balance. Well, if I wanted to balance, I give it a tolerance, say to the nearest 10 yards, 0 import, 0 export, and I say okay. And now you see 1187.3 cut and fill. It's now balanced, and it has changed the pad elevation to do that.
What did you change in the balance menu?
On this balance, I didn't change anything. There's a tolerance of 10.
Okay.
So it'll calculate to the nearest 10 cubic yards, and it tries to get exact. And so in this case, it's small enough, it did so. And then here's my desired.
Okay, I see. So even though you didn't change anything, just by virtue of clicking the balance button and then clicking OK, it automatically adjusts based on the tolerance.
It adjusted the height, it adjusted the elevation of the pad
Right.
to the point where the cut and fill balanced.
Okay. All right.
Now you got all these other things. You can move a vertex, stretch a corner out, do all these kind of things, rotate it, et cetera, et cetera. Write the 10 so it would create the surface from that pad.
Right.
All kinds of things. Now, one of the things to keep in mind about balance is balance doesn't always mean your cut equals your fill. Let's say I wanted to make this a borrow pit and I needed 5,000 yards of fill somewhere else over my project. Well, here's going to be my borrow pit. I just set this up, tie it into the ground, and I come over here to balance, and I say, I want to be able to take out of here 5,000 yards. And that may make it really steep. All right, so there it becomes that. And it sets the elevation down to 1,310.6. So it's close to that, the original that we had, it just coincidentally.
Right.
But it's all cut. And the cut, as you can see up here in my volume, 5,001.8. So it's close to 5,000. That's within that 10-foot tolerance. And you can turn that tolerance tighter if you want. But it's a really nice.
So the balance, I was just thinking, it's not only based on the export value that you chose, it also considers the tolerance.
It also considers the what?
You've chosen the balance setting and you're saying I need X cubic yards of export. It's not only looking at the value you choose for the export, it is also considering the tolerance value.
Yeah.
Process that.
Yeah, you can tighten it up. And so let's say if I wanted to make that instead, or let's say put it down to the nearest cubic yard, even could even do 0. I'm not sure. Well, let's try and see. And let's say instead of 5,000, I only want like 2,500. Still more cut than fill. And I say okay, and there it is. And there you can see up here 2,780 of cut and 280 of fill. So it sets this elevation from my pad, and I have to fill a little bit in here, but if I set that pad and then bring it into the ground, I'm going to get exactly 2,500 yards of excess material that I can take out and use somewhere else.
I see.
And so, and whether that's cut or fill, maybe you need to stockpile some material somewhere. So if you're, again, your balance can be, I need to put 3,500 yards of excess material within this spot. And it says, okay, just build a pad and slope it in. There's your 4.5 on the fill, 3 on cut. So I got a little cut back in here, but that once I create this pad, I will have used this 3,500 yards of fill to build that pad.
Right.
Okay. And again, then you've got things like, you can just move it if it's not in the right place, reprocess, and it brings that same thing around. Okay. So there's your 2541 versus 418. Actually, at this point, you need to rebalance. When we have 2500. Yeah, so it recomputes that. When I moved it, it just kept this and this and this and redid the pad, but that made these numbers change. And so you go back and rebalance again that once you've moved it, and that would be, this would be now how you would construct that area to be able to get that. Okay.
Okay.
So design pad is pretty nice in that regard. I'm going to exit this. I'm going to erase by layer. Again, here, erase by layer or on the layers toolbar. It looks like a pencil and a stack of layers. I'm going to clear, because that was from the last thing I was building over there, that sample surface. I'll select layers from the screen. I'm just going to select the pad. And I'm left now with my original polyline. And again, that's at a 0 elevation this time. So if you were to design pad template, just keep everything the same. We'll pick the pad polyline, pick the surface, and let's see, 4.5 and 3. Now, here it is, what I was going to show you earlier. Because we had an elevation on it when we started, it did not ask us this question. Now we have 0, but it wants to know what elevation you want to set this to. And it says the line above, the range of existing elevations along the pad that goes from 1311.33 to 1319.39. So if I wanted to put it in the middle, or if I wanted to make it at the lowest spot so that everything is in cut, or if I wanted to make it at the highest spot so that everything's in fill, then it would do that. So if I keep this at the lowest spot, which is already defaulted there, and just hit enter, and there it is, it's all in cut. Okay. So I'll say no to this one. No, I'm not going to contour the pad. I'm going to go back and erase by layer again and just hit enter because it kept it. And this is now still back to 0. So let's take a look at the other option of if I wanted to put a slope in there, and I'm going to put this slope at a -2%. Okay. I'll say okay. I'll pick my polyline, pick my surface, and now I'll keep 41 fills and 3:1 cuts. It wants to know the bottom elevation. Well, I'll keep that right at the ground here. If I want, I could make it lower, whatever your needs would be. And now it says pick the first point to define the slope direction. So I'm just going to say from here to here, I want it to go down to that corner. Or actually, I probably should have gone down to that corner so it can go over in the pond, but you get the idea.
Yep.
So if I put that there now, when let's go ahead and contour the pond this time. Not going to label, not going to write. That'll be fine. I'll say okay. So now you see the contours show the depth pad slope. And
so when I do this, it asks me if I want to adjust the parameters and redesign the pad. If I choose no, it does not prompt me to contour the pad.
oh, okay. You can do that with your version. Let's say they must have added that in as an automatic, but you can do that with if you say that you want to calculate the surface, and then it will prompt you for that.
Okay,
And right down here, see where it says contour pad.
I see. Okay, I must have that turned off then.
Well, mine should be off here too. It should.
Maybe is it possibly the version? The version.
Oh, yeah, that's what I'm saying. They've added that in. Even if you don't turn it on, they give you that option now.
Okay.
Okay,
All right.
so, but that's where you would turn it on. So now that gives you a way to have a draining uh, flat bottom, you know, it's no longer level, it's now drains. Now, if we let's take this, I'm going to erase by layer again. This I'm going to clear, and I'm going to select the contour layer. All right, so now I've got that structure. And I think we should be able to see the fact that it slopes. Maybe it's kind of hard to see it. It's so slight, but anyway, it slopes down corner to corner. Now, what we could do at this point is let's isolate the pad layer. And let's make a little surface here called pad. So we'll go to triangulate and contour and make sure my selections are not on. I'm going to not draw my contours. I'll turn those off. Triangulate, I'm going to uncheck those triangulation lines. I don't need to see those anymore, but I will write the file. I will hit select, and I'm going to call this pad. And I do want to use the inclusion exclusion areas because this outside edge is that closed polyline that I'll use. All of this stuff should be good to go. I could turn on densify, but see, I don't really need to because I've got the endpoints of all of these lines that are going to come into play. So there's no real benefit to densify.
And we want the interior to be, flat, right?
Well,
I guess
no,
that doesn't matter.
Remember the first thing we did when we offset the line only from the 3D offset command?
Yeah.
And we didn't have these drawn lines in here. Well, this line out here, this outside line, it has a bunch of vertices on it.
I see.
But
It's
our pad only had the 4 corner points, right? So in that case, I would say densify polylines and go every 10 feet, and it would drop points all along that outline to allow triangles to form there. But because I have all of these lines already drawn, I don't really need to densify. The only thing it would densify would be that inside frame.
And it's already essentially done just by virtue of having those.
Absolutely correct.
Okay.
Absolutely correct. Okay, so I'm going to say, okay, I'm going to read my prompts. There's my inclusion and finish selecting inclusions, no exclusions. Select my objects. And, oh, I must have canceled and told it not to. All right. So it drew my lines. It did write my file. Let me see why. It is, yeah, see, that was still on. I needed to say yes. I'll get that. No exclusions. I'll get that. And my pad's now done. And I can look at it, which would be, let's turn off the triangles. We'll show some contours there. And so that would be what that resulting pad would look like and how it would contour out. Okay, so now we've got that. Now, let's say that we've drawn the contours. Well, heck, let's just go ahead and you can draw them if you want. Up here on the surface, contour from a tin file, contour the pad. I don't need to worry about anything there because the surface already ends there. Go to contour, I'm going to draw the contours. Let's say every 1 foot. say okay. All right, so there's now the contours. And you see as they wrap around the fill and they wrap around the cut bank. And so I've got a downsloping pad. Now, let's say that up here was my 4-to-1, 4.5-to-1 slope. But I might need to say, I want to say, here's where my water is going to come. I may want to drain from here down. I'm going to cut a ditch in this fill face. Okay. And I want that ditch line to go at a, let's just try a -5%. I'm not sure if that's correct. But let's say 5% was as steep as I wanted it to be. The 4.5-to-1 is going to be more than 5%. And so I would go to my 3D data and my 3D polyline utilities, and I want to do a 3D polyline by slope on surface. Okay. This is the command Civil 3D programmers. They all say, well, why would you ever want to use that? All right, so here's why. So I'm going to do that, and I'll put this on whatever layer. Continue the polyline by steepest when the slope is less than target, and I'll do okay. The length limit for the polyline, let's just say 100 feet. I'll say okay. Now, we pick the surface, and it wants us to pick the origin point. I'm going to pick right there on that corner. And what is my direction, up or down? I want to go down, so I'll type D for down. Now, the direction of the 3D polyline when you're facing down the slope, left or right, and this is sort of it's a really odd prompt. And it's not real easily visualized, but what it is, if you consider yourself standing right here on this corner, and you're going to produce a 3D polyline that goes down the slope, what is the direction of that when you were facing down the slope? So you turn around and you look down the slope, and so the direction, if I wanted to go over on this face, I'm going to say to the right. If I wanted to come down this slope, I would say to the left. Okay. So I'm going to say right. And I choose, a percent, a ratio, or degrees. So if I say percent, now my design slope is going to be 5%. Now I said down, so it's going to take care of the negative. So I'll say down, and boom, there it goes. Adjust the slope, yes or no. I'll say no. It wants me to do another one if I want, or just enter it in. So now I've drawn this, which walks down that face of that slope at a 5% grade. Okay. I didn't just release it down here because that would be steeper than 5%, right?
Right.
So if I had some kind of need to do that, that's why that command is so helpful. And then I could use that and maybe, let's go ahead and extend this guy. Let's see, we will come out to here and say, here's my, yeah, if you double click it, you get the editor. If I've got a different, I've got a different menu in the AutoCAD version, or in IntelliCAD, so I could extend that. But if I simply did extend. All right, so I'm going to extend all the way out to Of course, AutoCAD's not gonna let me do it with the 3D. All right. Let's see here. All right, I know, even though it's got all of those points in it, you see all those different points where they cross triangles.
Mhm.
I'm gonna reduce the vertices, select that object, and now it should just be the endpoints. There we go. And so I'm going from that corner up there, really sort of, well, I'm going to get rid of that. I'm going to take this one and put it there. And I want to extend this by distance. And let's just run it out to say this far. And it still has elevation. Yeah. All right. So now that should be, if I look at my drawing inspector, I don't need the layer name. I don't need the direction. If I look at that, I see I've got a minus 5.04% because I tweaked this corner up here. Okay, so I could have made that, you know, exactly 5%. But it's still, you know, it's right on that surface. So what I could do with this in terms of making a ditch. All right, I want to make that ditch, say, 2 feet deep. So I'm going to go to 3D data and I'm going to change the elevation. Now that's a sloped line. So when I change the elevation, I can you know, if I make an absolute change to the elevation, it wants to know a elevation to set it to. So I could set that to a constant elevation. All right. So I'll escape that. And if I did it, let me turn this off. If I did change elevation to differential now, I want to make it, I said 2 feet deep. So I'm going to say go -2 feet. Ignore 0, doesn't really matter. I'll select this object. And so now it's sitting 2 feet below the actual surface, which is what I found the first time. So you see, I'm now 2 feet underground. Right?
Mhm.
Now, again, using design tab template, I could offset the edges here. Or first of all, I'm going to do an offset. I'm going to make this a foot wide in the bottom. So I'm going to do a,
Sorry, 1 second, Ken.
Yeah.
I'm having issues. So I've got the surface and I'm trying to follow along with drawing the 3D polyline by slope on surface.
okay,
But it's not generating a polyline.
okay. Let me do this. I'm going to stop my share. And I'm going to invite you to share your screen. You know how to do that with Zoom?
Yep.
Okay, so go ahead and share your screen.
There we go. Okay. So
I'm not seeing it. Stop your share and reshare it. Let me see what's.
all right. So
I may need to be over here on this screen to see it. There we go. Now I see it. Okay.
okay. So 3D data, 3D polyline utilities, 3D polyline by slope on surface, right?
Uh-huh.
So then,
Oh, look at the length limit for polyline. Give that make it 150. Well, yeah, anything.
okay.
fine. All right.
Add. Okay, down, right. Percent, 5. No.
And it still didn't. Let me see here. All right, I'm going to request remote control. Let me see what we've got. I did. Let me turn that on for a second. I don't think that was the difference, but if I start right here, I'm going to go down to the right. 5%. 5%. That went the other direction.
So I think part of the problem when I generated the surface, and what did I do? Oh, when I designed the pad, so I had this set to -2,
Uh-huh.
and I chose here and went this way.
Okay. That's
But
right.
it's still when you look at the surface itself, it's sloping towards the cut. I don't know if that should make a difference. I mean, because we're
Well, let me just take a look at what is that contour elevation is 13, 15. This one should be 16. Ah, it's going the other direction.
okay. So it seems that is impacting the way it wants to draw that ditch line.
Yeah, because it's finding that it can find a 5% slope.
I see.
What, but did you put in a 5% or a 2? You put in a 2%, right? See, that looks almost perpendicular. That implies that the slope is 5% along this direction.
Okay.
Let me see. Drawing inspector. And we'll turn off layer name, elevation. All I want to do is look at, oh, let me look at the, yeah, there's polygon direction. Slope is -2%. So, all right, so you're 2% and it goes down 2%. So you're climbing up to this point. Okay. All right, so let me turn off that. Oh, there we go. All right, so, and again, that being filled, and this should also be, make sure we're going down the hill. That's 13, 15, 13, 14. Okay, so yeah, this coming back this direction is causing that to be a problem. So 3D. Slope on surface. Let's find there. Pad. And if I start, let me start just off the corner a little bit so that I'm on this face. And I want to go down the direction the polyline went facing downhill. See, that was the problem. You were up here at this corner and facing downhill. You're also, this is also downhill. So I think if you'd have chosen left instead of right, it might have gone that direction.
Okay,
So if I do right, 5%, 5%. There we
okay,
go. All right.
okay,
No, enter to end. And there now is your line.
got it.
All right. So now, and I would just leave it like it is there. No need to extend it here. You'll see the same result. All right. So let's stop remote control and
Stop sharing.
stop your sharing. I will restart my sharing. Okay, so you're back with me now. All right, so I have a line that, and I dropped it 2 feet. Remember, I wanted to make it 2 feet deep.
Yep,
So you're going to go to 3D data, change elevations by differential, and make that differential -2. Select that line and follow the prompts, and that'll get you there.
got it.
Now, so we have what could be the edge of our ditch bottom. We're going to make it a foot wide. So I'm going to offset this 3D polyline. So my polyline 3D offset, and I'm going to do an interval. I'm going to say, okay, and I'm going to go horizontally a foot and vertically 0. So I'm just going to basically parallel that line just a foot away. Okay. So now I've got that one. Now I'd like to be able to trim. See, I'm used to trim being right there. And if I say trim boundary image, let's see. Yeah, see, AutoCAD won't let you trim with a 3D element. Let's see what we can do. If we trim, or let's see, break by crossing polyline. So here's our clip edge. The lines to be clipped are here. No, no. All right, so now these should be different, that I can just delete them. Yeah, there we go. I didn't want to get into a situation where I've extended off my surface here. So now I've got my my ditch bottom, and I can put the top of the ditch. Now I want to come up and intercept the pad.
Right,
You can do that again with the 3D offset, or you can do right on surface design pad template. Now be careful when you're doing this. Make sure you uncheck this erase previous pad entities at this point. All right, and I'm going to change the layer to ditch. And I'll go ahead and I'm going to tighten this up on the side slopes just so you can see them better.
sure.
So, okay. And I'll take this one, and now because it's not a closed polyline, it's going to ask me which side. Well, I'm going to make these 1-to-1 side slopes. Now pick the side. So I'm going to go up this way. I see what's going on. So just, yeah, I need to do that. Yeah, there we go. All right, so now the pad polyline is here. Oh crap, sorry. Time. Make sure the slope is off. So okay. Pick that, pick the pad 1-to-1 and this side. Okay. And I'll say nope. And onto the pad, nope. And I'll repeat the command and do it again for the other side. And there's my pad 1-to-1. Pick this side and enter. And now if I isolate, oops, keep missing, isolate that layer. And now I've got two little surfaces. I don't have the bottom surface because I didn't have that close, but all I have to do is shrink wrap this, or just allow the triangulation command. So I'm going to triangulate and contour. I'm going to not draw the contours. I will write the file, and I'm going to call this one ditch. And I will not use the inclusion, but I'll take the shrink wrap option. And it's all exterior, so I can leave it at none if I want. That should be fine. There's no need to densify. And I'll say, I'm going to turn the erase previous off so I don't erase my other contours yet. Say okay. Now select my objects. It now built that surface. Verify it. Ooh. All right, so that's why we verify. We've got some issues.
Oh,
And let's see what might have caused those issues. So if I look at this in that 3D, all right, so the geometry looks good. I see what's happened is that I've allowed it to jump across. How did that? But those should be acting as break lines. If I add in my ditch surface, yeah, see, it's going from here. If I take this, turn the transparency down. So you can see that this point at the end of this red line, it was able to jump all the way up across here and form that triangle, and that should not have happened. This should have forced it not to do that.
right.
All right, so how do we?
Would it possibly have to do with any of the tolerances in the surface generation?
No, I don't think so. For some reason, let's see, is that a 2D or a 3D? That's a 3D. Oh, here it is. It's only got a point here. It goes all the way down to the point down here. So I can fix that real quickly by redoing this. And let's just turn, we're just going to densify. And this time I'll densify it every 5 feet. And then that should take care of that, I hope. Let me take a peek at it. No, good Lord, what is going on with this? And this doesn't happen in the IntelliCAD version, but I'm not trying to beat up on AutoCAD. That's not an AutoCAD thing. That's something else going on. Let's see, there's that one, there's that one. Yeah, see that is by its nature a break line. I wonder if the fact that it's closed, oops. So that left it off there, that's good. And then that's closed. Now, I draw a 3D polyline, and I put it on the same layer. I go from here, 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 here. Same thing over here. Up. Meant to do a 3D polyline. No prompting, so it's going to read the elevations. I don't really need to do these. Yeah, I don't need to. I just need to go from here. And let's come back and take this one out again and just close the gap. Okay. Let me see what might be going on here. Say no shrink wrap reduction, or let's just say low. Let's see what happens when it draws that. More zeros, minimums, densify. It should be okay. So there's our boundary. That created correctly. Oh, sorry. Surface. Unbelievable. All right, if we did this, let's see. Triangulate and contour one more time. Grab all of this, but I'm going to deselect those. I don't really have any anticipation that that fixed it. Sure did.
So what exactly?
So what I did was when I decided to build this surface, I selected everything, but then I deselected these lines here. But I should not have had to have done that. That should have worked. So what I did is I triangulate and contour.
Okay.
And I said, okay. And to select everything like that. And then I held the shift key and clicked to deselect those two lines there, those two 3D polylines. It's really odd. That built,
correctly that way.
yeah, I mean, and that's why it's so important to look at this stuff to make sure that it's doing what you want. So that's my ditch, but I wonder if it's almost like that green line is not following where the red lines are touching it. I'm going to give this some vertical exaggeration and see. No, you see, it's right along those, runs right along the end. Now, see, I really should have been able to even get rid of this one.
Huh.
Now, see, I should have even been able to do this. Let's just say none here. And I should have been able to simply take this and this. Let's see what that does. Yeah, see, that's all the definition I really needed to be in there for some reason. And I do not know what that reason is. When I selected everything, it allowed the endpoints of these sidelines to look across, to jump across, and to form triangles across there. This should have been acting as a break line.
Yeah, it should have nodes at each of those red lines.
Well, these red lines do, but the green line doesn't.
Well, yeah,
Yeah, and it doesn't, it wouldn't need to. Just the fact that it's a barrier should prevent this point from seeing across to that point.
Hmm.
But it's not preventing that. That's an error in the programming. So anyway, find your way around it. We've got a good ditch surface now just by selecting those two bounding lines.
yeah.
Now, so what do we do with all of this? If I go back to restore my layers, so I now have that ditch. I've got a pad. I'm going to erase my contours for now. So I've got all of this stuff. And I've got individual surfaces. So that's what that ditch would look like. You see the high bank. Well, I'm in a 3x vertical. All right, so the high bank's a little bit deeper, and then you come back out because it's further down the hill. It's not quite as steep. But that would be the ditch that I would cut into there to allow this pad to then drain down at a 5%. All right.
Right.
So how do we put all that stuff together then? Is we would go to our triangulation file utilities. It's on the surface menu. And we're going to load up a base 10 file, and that base 10 file is going to be my pad. Okay. And I can turn the view on like that and spin it around a little bit. It's sort of like the viewer, it's not as extensive. So let's zoom this around to there so you can see that edge. And then I'm going to go next down there at the bottom. And now I have some things. I'll turn that back on. Apparently it didn't stick. Okay. So I've got some things that I can do in here with this surface. I can, add, I can enhance the flats, I can smooth it out, do all kinds of different things. But what I want to do is I want to merge another 10, combine two 10 surfaces. So if I merge the 10, and we got these different options, just take the default for now. And I'm not going to set the colors. It's one way you could, but, and it just colors the triangle. So when you're in the surface viewer, you'll see those colors. And so I'll say, okay. And it now wants me to pick the second surface. So there's going to be my ditch. Open that. And now you can see that I have created a new composite surface by putting the ditch into the pad. At this point down here, my output portion, I'm going to check that I want the insides, the border, and the outsides, and I'm going to do a save as. And I'm going to call it pad ditch. Okay. Now, all that's done, and I could, at this point, contour from a 10 file. Let's do my pad ditch. Draw the contours, 1s and 5s. We don't need to worry about the inclusion because the surface ends at that inclusion already. I don't need to densify anything. I'll say okay, and now there's the contouring. And if I freeze these pad layers, ditch layer, let me freeze that one too. Then there's your grading plan to build that surface. And then if you had the existing contours on as well, which too far out to be able to restore, let's just come down here and turn them on. The topo, minor, obstructions, obstructed, and major, labels, and major. So you can see they tie right into, where it's supposed to hit. Okay.
Would you mind stepping me back through how to merge those? I was still trying to fix the ditch line. I'm having issues with that, but
Yeah. Okay.
I'm going to skip over that and just merge the two, even though that.
Yeah. So what you would do then is go to your triangulation file utilities.
Oh, file. Okay. All right.
Okay. And then the first step is to load a 10 file. So you're going to load the host file, the parent file.
So
In that case, it's pad.
Okay.
Okay. And then you're going to hit the next button. I'll go ahead and close. Oops. Let's go back to that. I'm going to have to put you on hold for a real quick second. I got to take this one.
Yep. No problem. I'm going to use this moment for a bathroom break.
Okay. Okay, Jacob, I'm back if you are.
Yes.
Okay, good. Sorry about that. My car's been in the shop. They've had to keep it. It was supposed to have been done last week. I wound up in the hospital. I rescheduled. It was supposed to have been done Wednesday. They said, no, we have to keep it overnight. Okay, fine. Just get it to me tomorrow after 5. And then tomorrow after 5 came, and we had to keep it another day, and yada, yada, yada. So anyway, it's a new Ford Explorer, and it's got the moon roof on it. It has started to rattle a lot, and they had to replace the entire unit. So that wound up taking longer than it should have.
Yeah.
But anyway, they got it, and I took care of all that, and they're going to actually deliver it. I don't have to try to get over there and pick it up. So
All right.
yeah, good deals. All right. So now you have loaded your base pad. You hit next, and now of all these different things you can do, the one we want is this second button down on the left in this bottom cluster that says merge 10.
Yeah.
All right, and we're going to choose this first option that is set. The second 10 is inside the current 10, and the outside boundary with the transition. So it transitions between the two to stitch up any differences. Now, we don't have any differences because we did the pad intercept up to the daylight line hit the surface. So there won't be any transitions that it does, but it can fill in the gaps if you've got some ragged holes in between the two surfaces. All right. And then unchecked everything else. I said, okay. I went out and then looked at ditch, and I see that it's now merged into that surface. Okay, you get that part?
Yes, minus the issues we were having earlier with the dish not having contours jump across. I can figure that out.
Oh yeah, you still got those little steps and stuff in there. That's fine.
Yeah.
But this is how you go about doing that. Now, once you've got this done down here at the bottom, if you want to save that as a new surface, check those items that you want to output and then do a save as.
Okay. And that was pad dash ditch.
Yeah, that's what I did with that. Okay.
Okay.
So I'm going to say, no, I've already done mine. All right. So then, and then this, I just did contour from 10 file. I also see I left off one other topo. Topo major square. Oh, here it is. Topo major. Yeah, so now all of my contours actually tie in. They hit the existing ground, and the ditch, of course, incorporates as part of that overall surface, right? So now this is the same way. Let's say if this were going to be a parking lot, and it was going to have, let's see, let me isolate. I'll isolate just the contour so you can see where we're working. So if this were a parking lot, and let's say we were going to have some parking islands and stuff in here, a lot of times, we try to draw that stuff and then set the elevations for everything all at once. But the easier way to do that, just like we did the ditch, is that we would draw the, say, the parking islands, and then put in whatever that radius is from here to here. Oops. Let's undo that. And then, you know, maybe we'd had another one. Like so, get rid of, say that, extend. Why does it say that? It worked. I don't understand that. When I went to extend and it said pick, see that little marker, that the circle with the slash in it, that means it's not used for that, but it went ahead and did it. Oh well, anyway. And then we would say let's trim. Oops, I see. I know what's going on. They've changed, AutoCAD has changed the way trim and extend works. So I need to trim that and trim. You're supposed to just pick the things that it's trimming. Okay, so there we go. And then I would do the same. Trick here. Then I would join this all up. Join nearest. Gap. Just should be all good to go. I'll take that and that. Now that's a representing my island and my parking lot. Now, just like I've done before with the ditch line and other things that I've got a 2D polyline, but I want to drape that on that surface. So I'm just going to go to 3D data, 2D to 3D polyline by surface model. And my pad ditch is my surface. Here's the object I want to drape on it, and use current elevations. No need to worry about that. I'm not going to keep the existing. And I'll just say okay. All right, so that now is a 3D polyline. And it has, you can see this elevation here is what, 1314.75. And it comes up to here and it's 1337. If I look at my drawing inspector and just simply look at elevation, you can see it comes up here and it's going to approach that 1314 contour right there, crosses it. Same thing here, 1314. And this is going to get closer to 1313. What have I got here? I've got 15. Ah, my slope goes backwards as well. I think so. We put a -2% and it said the slope direction. Well, it really worked backwards than it should have. But anyway, if that's the case, you would know to just pick from here to here or put in 2%, go from here to here. So you verify all that stuff, you know, before you get along. But anyway, we've now draped this on the surface. So if we're going to make this into a curb situation, all we do now is take this and we'll do an interval. And we're going to go, the horizontal offset amount is just going to be 0.05. Vertical amount is 0.5. Let me take this and go to the inside. What did I? Earth. Select side. Okay, here. So now there's that one. I'm going to repeat that offset interval. And I'm going to horizontal amount go a half a foot, but 0 there to there. Now I've drawn this as my curb structure. You would make a little surface out of that and merge it into that composite surface. You just keep doing this piecemeal at a time. And then what I do with that is another little trick here. If I take, I'm going to draw a 3D polyline. I'm going to go from roughly this midpoint over to this one. Do another, say from here up to, let me jump there, there we go. Now I would really have drawn these at the midpoints and all that, and I would, break these things off. If I trim. Get rid of these. So now that went from here all the way across, set the elevation. So that's at some slope. It went from here up to where it hit that at some slope. And I'm going to take both of those two lines and I'm going to raise them up. So I'm going to go to 3D data, change elevation differential. And I'm going to raise them up, say 3/10 of a foot. Matter there, go from here and here. Okay, so now they're raised. And if I look at that in my viewer, you see how they're sitting. These lines are sitting just above what would be the flat distance across that island. Okay.
Right.
So then I would triangulate and contour. Write the file, call it islands. I will use the inclusion perimeter. Or 0, I'll go ahead and densify. 10s, yeah, 10's probably okay. We'll do 5. I'm going to turn my contouring off for now. I'll say okay. I'm going to pick my inclusion perimeter as that outermost one. No exclusion. And now select all of my geometry. Verify it with a view. And I see, yes, indeed, it did exactly. I can see that crown. I can see how the contour runs up the face of the curve, goes across the back, comes around that crown slope. Same thing it does right in there, okay? Then I would simply do the same thing I did before. Triangulation file utilities, load up my base. This time my base is my pad ditch. Next. merge. Choose my island. Peek at it here to look like, yep, there we go. It's right on there, and you can see now this was a flat surface. It wasn't planar, but I mean, it could have had a ditch in it or a swale in it, and that island would have followed that swale. But you see how everything comes into play. Now, I would probably fix this in here. I would tie that up to here and you know, work on that a little bit. But or you would also recognize the fact that, you know, they're going to go out there and mulch the shrubs in that island. It's not going to be that big a deal. Just let it go. Okay, and then you would do a save as and call that pad ditch island. It's now saved. Exit that. View pad ditch island. Let's see if I've got that transparency on. So now you can see I've got, you know, in a pretty simple, straightforward piecemeal fashion, I've graded all of these things together and merged them where I need to merge them. I can then take this, I can tie an access road into that. If I turn everything on, freeze my brake lines and such, you know, I could turn, let's get rid of those contours, let me freeze those. Contour again from tin file, pad ditch island. I think everything is good. 1s and 5s, yep. So now, of course, I would have, you know, had a different layer. I would have kept the island. I think that was on a layer. I think it was on brake line. Nope.
So you erased everything except the parking pad outline, and then we're just regenerating the contours essentially.
Yeah, I don't recall. Let me see, what layer did I put that? I froze that back off. Oh, I must have erased. I must have drawn that the islands. I must have drawn on a different layer. I don't know if I can. Yeah, I can't do an oops.
That's okay.
Anyway, you get the idea. So, you know, do this stuff, do your design work in pieces and start stitching them together. And it's a lot easier than, let's say you draw the outline of the parking lot, you draw the island, you do all that kind of stuff, and you try to do all that stuff together before you create the surface. Well, you have to start and calculate, you know, what are the edges of the island? What are they going to be? You don't know yet, but you do know that you're going to have the overall floor of the parking lot, and you're going to just drape the island right on it, or you're going to put a ditch in, or you're going to put a pipe under the ground. You're going to drape it on a surface, drop it if you need to, and then just use that geometry to build these things piecemeal. And then, of course, you can also do, under your triangulation file, utilities, we're going to load that pad ditch island. We'll go next. Oh, I'm sorry. We'll go back. Come out of it and come back in. We're going to load existing grade. That's what I meant. And then we're going to merge pad ditch island. And there's your overall final grade. At which point you could do a save as. Let's call it final. Oops, sorry. Cancel it. Export. There we go. And then, of course, we verify that. And there it is. Minus the drawn outlines of the island, we should have kept those on a separate layer and all of that. But you get the idea of the workflow. That's essentially what you're going to be doing is individual pieces. And let me show you one other quick thing with design pad. We won't go through an exercise, but I want to show you the option. Under design pad template, you have an option here called multiple pad polylines. And then you set up, you tell it the layer that they're on and your desired cut and fill slopes, and which you set the order that this works. Okay. So what that's useful for, let's say you're doing a subdivision and you've got all these house pads sitting around in all these lots. Well, you may also have, you know, a pond that you've designed with the pad template. And you can do that all in one shot, and you tell it which one to do first. And what it amounts to is that, let's say I did this with pad, I wanted to set these at a particular finished floor, and so they're going to have a tie down in. But let's say when I do this one, the fill slope would extend over into the area where this fill slope also hit. Okay. So they would overlap. You know, those daylight lines would overlap. So when you choose that multiple pad processing and you give it the order, you're telling it, let's say, do this one first. So it goes out there and creates that, and it temporarily in memory adds that to the overall target surface. So now when this one processes, when it's its turn, it goes out and it stops when it hits the fill slope or cut slope from this one, and it no longer targets that existing ground in that area. Okay, so that's just a way of doing what we did individually up here. You can do it all together, you know, in one shot. You just have to keep track of the order in which you do those. Okay.
Where do you get to that? Is that under the utilities again?
No, that was again under design pad template.
Okay.
And it's this right here where it says use or process multiple pad polylines.
Okay.
And that's where you set up, you tell it the layer that those are on. And then give it desired cut and fill slope, and you can change, you know, their.
So you don't, do you necessarily have to have all those different pads on different layers, or you can just have them all on one pad layer?
Yeah, you can have them all. Let's see if we can do that with this up here with these. I'm gonna try to raise those. Let's just try an example. I'm not sure. I haven't run through this data to see if I'm gonna blow it up or not. If I process multiple pad polylines, I'm gonna call this one buildings. And if I set up the layer, it should be building outline. There we go. And let's say we're going to do 4:1 on both of these. Now that's the only layer I've got. Okay. So I'm going to say okay. And say okay. Now it says, all right, pick my surface. In that case, I'll go ahead and use the final grade. And now it says select the pad perimeter polylines. I'll do this one. This, oops. That one. Let's do that. So that one. That one. So that one. So the only thing that you're doing with the layer is you're telling it you can have different side slopes for the different materials. Okay.
You want one pad to tie out at 3-to-1. We want one to tie out at 4-to-1.
Yeah. So
That would require them to be on separate layers.
correct. Yeah. But if the houses all had 4-to-1s and the ditches all had 1-to-1s, you could do house and ditch. And then when you pick these, you pick them in the order you want them to process. And then you hit enter. And let's see what we're going to do here. Range of existing is 1322 to 1324. Let's make it 1330. So it did that one, and now it's going to the next one. I guess it goes in reverse order. So 1301, we'll make it 1310. And now we're up at this one. You see it's highlighted. We'll make that one at 1315. I'm trying to get where they're going to overlap. All right, so we'll make that one at 1315 as well. And now watch what happens here. See how it went over here and it trimmed it off?
Yeah.
Now we got a problem here. Let's see, we'll make that one 1315 as well. Let's see what happens. Okay, yeah, so see it, it also took this one and it hit this one, had it already been done. So it stopped it at the edges of that, but it also still went out when it's not overlapping these other pads, it still targets the original. And let's go ahead and create a new surface and we'll just call it mess. All right. And if we look at that, you can see how it tied all of that stuff together. You see right there how, you know, this one did first and it went way out here and it got inside this building. But then when this one processed, it pushed out until it hit this.
Okay.
So now if we were to do that individually, we would set this one, get that done, make a new surface. This one, make a new surface. We do this one and make a new surface, which extends out into this one. And then we go to this one. And the target that we're going to use is going to be this new composite surface that included this one, and this one, as well as the existing around here. And then it targets that and stops where it hits that other pad. So it's just a means of
two different ways of achieving the same result.
Yeah, and it lets you do all this stuff automatically instead of having to stop and gather up and combine surfaces and then use a new target surface and then do the next one, combine that, merge it, make a new surface. So it keeps you from having to do all that. It does it all for you internally in memory.
Yeah.
Okay. Now, that brings up an interesting question. What happens if I do this? I'm going to move the pad from here to here and process. Interesting to see. Aha. So once you do that, if you make an edit to that surface, excuse me,
Great, so it looks like.
or to that pad structure, I mean, it will only work on that single pad. So you would have to go back and redo all that part individually. Now I'm gonna Put that back where it was. There we go. Okay, so get a sense of how that's working and how you do this stuff.
Yep.
You've always got targets, and you're going to tie those into it, and just generate the geometry. Look at the geometry. Like we had that problem with the ditch down here, and so we had to figure that out. So make sure that you always view that stuff to see that it's doing what you want. Don't do like so many other people they'll do this stuff, they get no errors, and they go, oh, good, I'm ready to go. Then, and they'll send it off to somebody on a bulldozer, and he's trying to dig that ditch based on that surface information, and his bulldozer goes crazy. So, and that's why a lot of engineering companies say, well, I'm only going to give you a PDF file, to the contractor. He says, so you're going to have to figure it out from the contours. Well, then he's got to go back and rebuild everything himself. Whereas, wouldn't it be great if the engineers knew what they were doing with all this stuff, did it correctly, and they could confidently then hand that off to the contractor and let him go on and get the stuff done? Saves a lot of money, saves a lot of time, saves a lot of errors. But, that's sort of wishful thinking when you've got competing companies. So, anyway, you know what I want for Christmas now. So, all right. So that, I think we'll leave this for now. Let me see if I don't think, yeah, they keep changing my license. I wanted to show that there's a module called CADNet that lets you go out and grab a Google Earth aerial image and drape it into, well, you can still do that anyway with the GIS. Images, let's see, place a Google Earth image. And we'll just call that image. And we'll go from the screen, and we'll go from here to here. And that's fine, go okay. And it's going to go out to the internet. It's going to find the imagery and place it underneath their site. And of course, we can tone that down a little bit.
Was that under GIS data or GIS tools?
It was under images.
Images, okay.
Yeah. All right, so it's not letting me, there we go. Now this being Google Earth, it's not appreciably accurate. It's okay, but if you let me freeze off some of these pad things here. It's because you see this parking lot edge back here, and how the actual photogrammetrically compiled data is this purple line.
Right.
Okay. So, and that's simply the limitations of that Google Earth image. But there's a thing under CADNet, and I can't show it to you because they keep, I keep having to go back and ask them to give me the license to use that. And every time they come up with an update, they forget to include that. So, but what you can do with that is it has a command called rubber sheeting. And you're able to go in here and you say, all right, take that point, make it that point. Take that point, make it that point. And you put these all over the site, and then it does an affine transformation on the image. It does it pixel by pixel, and it warps that image into fitting the exact ground measurements. And it's really, really helpful, I think. And that requires CADNet. That part of it is to do that rubber sheeting. Now, if your workflow doesn't get into that, what I caution people about doing is, if you use these Google Earth images, don't come in here and take these compiled surveyed or photogrammetrically compiled data and move it to match the image, because that image isn't that accurate. It's just Google Earth imagery.
I mean, yeah, it would make more sense to just move the image into place, right?
Yeah, but it's not, you know, even the scale, like if I did this and just said, move, and if I moved, say, you know, this to here. All right, so that fixed that little corner, but you can see, you know, it might have, you know, it's not too bad. There's a little bit of miss over there, but you know, somewhere else over here, it might needed to have moved a different amount. That was odd. It actually worked fairly decent. So, you know, you could do it. Here's a case. You can see where the corners don't really match up very well here. So if I move last here to here, all right, so I fixed that corner, and now I come back up into here, and I may have some miss right in here, you see. So it needs to sort of scale locally. Everywhere you put control points, it will do that.
Hmm.
It's what they call rubber sheeting. So it does differential scaling on that. Now, the other option is, instead of using Google Earth imagery, is if you had from the photogrammetrists, and sometimes you can get that, they can produce for you what's called a digital orthophotograph that is absolutely rectified to those same coordinates. And that way it will line up exactly when you insert that. And they'll usually provide a world file. So you would place an image by world file, and that maps the pixel coordinates to the ground coordinates. So
This may be more regarding settings on my end, but if I can't replicate the Google Earth imagery that you just had in there.
uh-huh.
I don't know if it's a setting or if I don't have like
Well,
real world setting turned on or something like that.
well, here's what it requires. It requires it to be in a known coordinate system. And I'm not sure what yours is. If you go up to your settings menu and look at drawing setup.
Yep.
What does this say right here under the projection?
So mine is set to Virginia, so that might be one.
That would do it. So PA South would fix that for you.
Okay, so if I switch to PA South, click OK, and then I would go into images.
Yep.
GIS menu.
Yep.
Google Earth image.
Uh-huh.
Create a name for it. Say aerial imagery. And then it prompts me to either pick from the screen or use map.
Right, and if you say use map, it loads up like a street map that you pick, but you've got to just use your screen and give it the lower left and upper right corners.
Okay, resolution high, map type aerial, set, place in background, okay. Okay, it looks like it's pulling it in now. I was in the wrong state. Probably.
Yep. That'll do it.
Okay. All right, cool. All right, yeah, I got it in.
Okay.
Fantastic.
Let's
I'm gonna have to remember to set it back to Virginia before I'm done.
yeah. Yeah. So, all right. So there we go with pretty much all of those tools at a pretty deep level.
Yeah.
The other things, like you've got these things like design pond, a bench pond and a valley pond, and all those are really just variations of everything that we've done before. Bench ponds are like design pads. You know, you just basically, you'll have the floor of the pond, or you'll have the outside edge of the pond, and you go down in to set the bottom level, or you'll go from the bottom levels and come out to set the top edges. And of course, bench ponds will let you put in some benches, and I'll leave those, you know, to your own exploration.
Okay.
Volume. And there's one here called stockpile pond and pit volumes. That's nothing in the world more than just a crutched version of doing a simple surface to surface comparison. but it lets you draw like the outline of a stockpile. And it has to be on a particular layer, and you choose that, and it sort of builds all this stuff with grid files in the background in memory, so you don't really generate all of those differences. But one of the things, like, let's take a look at our volumes by triangulation, and let's do a 2 triangulation surface volume. And we're going to look at our first prompt up at the top. It says select the existing surface. I'm going to start out with my raw existing grade. And now it looks like the same box, but up here at the top, it says now select the final surface. Well, I'm going to take that pad ditch island and see how much earthwork I'm going to have to do that work. So now I've done that. It wants if I can set an inclusion polyline. So maybe I've got phase boundaries or anything, but I'm going to take the whole surface. So I don't really need to select it because it only goes out to the extent of the smaller surface. And then no exclusions, but those are just ways it takes the numbers out of those drawn boundaries if you ever need to. Shrink and swell factors at the top, volumes, areas. This calculate elevation zone volumes. That will calculate the volume of earth between, like, say, from 20 to 25 feet worth of cut or fill, how much is within that. You can report tonnage if you know the density of whatever it is your material is. You can write this 10 difference, and that would generate a surface of amounts of cut and fill, or what we call an isopack. All right. Okay. But you can also do that. I'll show you where you can do that in another spot here. All right, we just say okay, and now it comes up with this report. There's our cut volume in cubic feet and cubic yards, our fill volume, cubic feet and cubic yards. It gives this a couple of other things, and these are good to know about. We've got 25,000 square feet is in cut, 18,000 square feet is in fill, and the total area of that new final grade is this, just over an acre. And we have
that should be the area of your parking pad, right?
That is correct. Yeah, that's the total inclusion area. So it stops at the smaller boundary.
Got it.
So, or if I had drawn, like I said, I may have drawn individual, just phase boundaries. So I want to know how much I'm going to do in phase 1, then phase 2, phase 3. So it stops the calculation at those boundaries. It's not necessarily a surface boundary. It often is
a phase boundary.
Yeah, but I mean, it could be any boundary. You could say, well, I want this crew to work on that part, that crew to work on that part, whatever. Now, this part that I've highlighted here, this is an interesting little bit of summation that is really helpful. It's going to tell you the average depth of cut and fill, of course, and the ratio. And then, of course, it gives you the volume of total export in this case. If I had, so I'm hauling away 1579. If I had more fill than cut, it would tell you that difference. But these last 2 lines, the elevation change to reach boundary, if you took that, and what it does is it takes those numbers above and it figures out that it's an area and cut, area and fill, and it makes that into like a cube of those dimensions. And then it says, if you want to now make that cube balance, you need to lower that total elevation for that site by 0.973 feet. So if I drop the elevation of that pad ditch island by just under a foot, I would probably get close to my balance of 0, 0. And the next one is the volume change per 1/10 of a foot change in elevation. So every 1/10 of a foot that I go up or down, I'm going to be either decreasing or increasing my earthwork by 162 yards.
Okay.
The reason this is a good number to have I was working on a job up in upstate New York for Lockheed Martin, and they were building a new hangar facility to work on the president's helicopter, Marine One. You know, there's a whole fleet of those, not just one. But so the architect up there, he was the in-house architect for Lockheed Martin, and we had, you know, our architectural department, you know, had designed the facility and based on his his desires, and we sited it at this one spot that really the only place on the campus that we had to put it, based on all kinds of other constraints like, you know, flight approach patterns and visibility from the towers and, you know, all that kind of stuff. And we were real near a wetland at the bottom, and so, you know, we designed it and did all the earthwork for building the pad and to make sure that the fill slopes weren't going to impact the wetlands. We had a little bridge going across part of the wetlands and all that. It was all looking good, and it had I don't know, whatever total cost that we came up with that it was going to take. So we're all sitting around the table, and the contractor's included there, the earthwork contractor. And the architect goes, "Oh, that looks great, except, you know, as we come in from the front gate and we're coming up the hill, it really is not, it's not, you know, you can't see it. I'd like them to be able to see this, make it stand out, be a showcase. Can we just raise it up to like 2.5 feet?" And everybody said, "Well, yeah, we can." And the contractor said, "Yep, that would be, you know, $4 million. And the architect goes, "What? You mean just to raise it up 2.5 feet, it's gonna be $4 million?" He goes, "Yeah," because he knew this number. So 2.5 feet is 25 of these 1/10, you know. So he knew how much this number was, and he knows how much it costs him to bring in that much dirt. You know, so he took that and he multiplied that by his unit cost and he said, that's going to be $4 million. And so the architect, you know, learned the lesson right then, because he knew it right, you know, out of his hip pocket, because he knew those numbers right there.
Yep.
So that's
Moving
nice.
dirt is expensive.
Oh yeah, it is. So anyway, so that's how that goes. Now you can save that drawing if you'd like to keep it and work at it for. We're not going to use it any further.
Okay.
So what I want to talk about next, before, and we'll sort of set the stage for when we come back after lunch, because I want to hit that road design stuff pretty heavily, and we're probably need to spend most of our afternoon on the road design stuff.
Okay.
But what we've done here is, if I go back to my exercises, and this is up in the background information before we get into the civils, this putting it all together. And this is the one that steps you through. You have a drawing that has a bunch of points in it, and they're not in a coordinate file, but we take them from the drawing, make them in a coordinate file, we get all that kind of stuff, yada, yada. And then we isolate these outside points. That's the outside edge of a little stockpile. And we use it to compute volumes and create a surface. And you see, here's the stockpile, you know, computing the volume. And I like to do it with just that 2 surface triangulation, just the one we just did. Now, like I was saying, that specialized one on the surface menu that says stockpile pond pit volumes, it does the same thing internally, but it let's see, it you know, it sort of insulates you from having to keep track of surfaces and merging and doing things like that.
Okay.
So, you know, people that do nothing but haul rocks around in stockpiles and stuff, that might be, you know, easy for them to do. It's sort of quick and dirty. It's not as accurate because it uses gridding instead of triangulation, but in any case, it's the same kind of thing. So all you really need are 2 surfaces, and you can do the comparison. And then the rest of this was just like we did our little pad. We have a pad for the stockpile. We made a borrow pit, and then we merged it into that surface and all the different contouring and stuff. And then we built this access road into it based on, that existing ground profile. And we designed a road profile right over here. And then we wound up with a 3D polyline that we could offset the road edges. And then we used that 3D offset to a surface, or we could use design pad template to take those outside edges, tie them down to the target. And that's what gave us these contours here. And, these fill banks here and the fill bank there, and cut. And we cut through the cut bank of the borrow pit for our road surface to come in here and drive in at that same, at that elevation.
Yeah.
So that's what, and I'll leave that for your own homework.
Okay.
So, but we're going to focus more on this road design, because I want you to see those tools and get into some of that, especially with the template development. Now, this business here, where we do this little road design, and then we sort of take a little side trip and we put a building pad in here. We do a building envelope, and see here step 6, we go to 3D data menu, choose draw building envelope. And that's this black outline around the pink building pad that becomes the building footprint that has this black outline for the pad. And we have a little parking lot, and we set those slopes. We've already done that kind of thing with that point editor.
Yep.
Okay, and then we processed multiple pads, and that's where we got this one hit the other. But now we need to take that and get rid of that raised hump. And so all of these things are going to step you through that night. We're not going to really have time to go through all of that and also get the road stuff. So I'm going to focus on the road stuff first. You've done, with what we just did, all of this kind of stuff already. Okay, but you've got the data files and you've got the step-by-step showing you here. So use that for some practice. Okay. And then when we come back after lunch, we'll hit the road design, pretty heavily.
Okay.
And go from there. All right. And that should probably do us. So any particular questions that occur, of course, let me know before we're done for the day, and we can stay late if you need to, but
Okay.
I think that'll wrap you up with the materials. So,
Right.
Now, that being said, it's 5 minutes to 1. I'm going to give you the extra 5 minutes, so we won't start back till 2 o'clock.
Okay.
And we'll take it from there.
All right. Sounds good, Ken. Thank you.
You bet. See you in a bit. All right. So, hope you had your meeting okay and all of that stuff. I was expecting, they were supposed to bring my car by between 1 and 2, and haven't heard from them since. They called at 12 to say they were going to do that. We still haven't made it, so we'll see.
All right.
Whatever happens. Anyway. All right. So what we're basically going to do, and I'm not going to sit here and teach you an engineering course, but basically what we have is in terms of designing these roads, as opposed to that little upfront exercise that I was showing you about, how we just offset that 3D center line for the edges. This is more in line of your old school template based roadway design, where you're going to have an alignment horizontally, and along that alignment it needs to go up and down vertically. There's our profile. And then we're going to have a cross-sectional slice of materials that compose that roadway. That's in our template. And then we're going to push that down the alignment and raise it up and down based on the profile. And then take the edges of where all of those things hit and tie them back into the existing ground. So there's a couple of things that we need in that approach. Right here they are. And this is on what, page 60. Is you have to have this center line, a profile, and a template. And then that will generate that 3D geometry and add it into our drawing. And optionally, it says you need a surface design that defines the existing ground. Now, RoadNet itself requires you to declare an existing ground surface, even if it's a dummy surface and you don't choose to tie it into it. The standard road design tools don't require that, but RoadNet itself does. It won't process without something declared. All right. So what we're going to do is take a look at this process through a couple of those steps. And we're going to take a look at the individual design tools, like designing a center line, designing a profile, and see how they work independently of each other, and then see how RoadNet ties everything together into a single clearinghouse, if you will, sort of like design pad template, sort of put everything all together in one box to let you do it all at once. So let's go ahead and open up roadway design base and get back to that here. Yes, so roadway design base will be the file we need to open from our data set. And it will look like so. Looks like we got shades of brown here instead of, like in the book, they're blue and red. That was done over there just for some printing purposes.
Sure.
But so we have here a piece of ground with some contours on it. And we have a starting point for an alignment, and we have an ending point for an alignment. There are no curves in it yet. It's just indicating where it's going to be. Now, a couple things to notice here. I see contours, but if I hover the mouse over one of them, the whole thing lights up. So if I select that, I look over in my properties and I see that that is an ACAD proxy entity. Okay. It is actually the IntelliCAD side of this software actually goes ahead and calls it a Civil 3D surface and gives you all the properties of the surfaces over there as well. But the bottom line is that this is something that can't be worked with as is. You have to do a couple of things. You can select this proxy entity and explode it and get it down into its component polylines, which I think are just going to explode into little individual segments, and then you stitch them all together and you build a surface from that set of contours with all of the attendant problems of doing it from contours. Now, also though, because it says it's an AutoCAD proxy entity, that should give you a clue as to a couple of other things going on. Another clue to look at is if you just orbit this thing up, you see, there's those old side skirts, as they call them. If that's all still part of that whole same thing. And if you're familiar with how Civil 3D and Land Desktop and all those things work, this is actually from an AutoCAD Civil 3D training data set that they use to train you how to build a surface and build roadways and all of that. Okay.
I have a quick question regarding these ACAD proxy entities.
Yeah.
So something I've noticed, at least in my time here, since we're using primarily Carlson software over regular AutoCAD, a lot of times we'll receive information from another firm or something like that, and they use Civil 3D And so the files we get from them will include a lot of these ACAD proxy entities.
Yep.
And one of the issues that seems to create for us is that we're, regardless of what object we're trying to select and do this command with, copy to clipboard does not work in drawings that have proxy entities. At least that's what it seems to be.
Okay.
And so, I mean, I just tried it right now,
And of
just the
course,
regular Control C command, and did not get that error.
yeah.
But I'm just curious if you've encountered that before. I don't know how much.
Yeah, I never have encountered that. But to be honest with you also, I don't do it a lot. I mean,
Right.
I do it when I need to move stuff back and forth, but sometimes I may just, take this and make a copy of the overall file and save it as a new name. But if this is something, say I wanted to put in, another file, you're saying if you select this and you want to copy that one, it's not letting you.
Yeah. So again, I don't know what actually triggers it.
Mm.
From what I can tell, it seems to be because of the proxy entities. I'm not getting that same error message with this particular file
Right.
for whatever reason. But I know, like on a particular project that we're working on, if we try to do copy to clipboard, whether it's through the right click menu and doing clipboard and copy there, or just doing the Control C command, an error message pops up and says copy to clipboard failed. And so, yeah, so I mean, if you've never encountered that, that's fine. I mean,
yeah, I never have on anything, and I do proxy drawings all the time. So
now,
yeah,
I know there's a cleanup utility that also is supposed to kind of, I don't know if
right.
it gets rid of them entirely, but it helps to,
Yep.
I guess, kind of.
It
dumb
does,
down.
but but let me show you the first step even before the cleanup. I think you can get, although cleanup would also work, but as we can actually read this, as long as if you know that this is coming from Civil 3D, then it has a certain set of data that you can't get to. All you can do is look at this. You can explode it and get what created the picture of what you're looking at.
Right.
But this is, now I'm going to point out a couple of things here too before we go further.
Sure.
See these contour lines that do stuff like this and this and this over here. I mean, this is a very poor contour map, very poorly done, very poorly modeled surface. But we're not going to, spend our limited time on trying to fix that. We're just going to have to live with what they give us.
Yep.
But we'll deal with it anyway.
Yep.
So the first thing that we're going to want to do is we're going to want to extricate the surface from this if it's included. Now that surface should include, data other than just the contours.
Right.
In an ideal world, however, I think the surface that they have included here was done just from contours. So it's going to be as if you exploded this and just did it without any break lines and all that kind of stuff. So, with that understood, the concept is valid in that we want to use the surface that somebody has already created that they're delivering us the contours for. So that's what we're going to look at. Okay. So we have a couple of choices there. One you said was in this cleanup. So under file drawing cleanup, there is one of the options. I'll uncheck all of these. You can see that it says convert Civil 3D / land development desktop AEC contours and points into Carlson format. All right, so that should take care of that and any kind of coordinate points as well. However, you don't have anything in here that says convert, alignments, convert parcels, convert things that you don't see, but maybe they're still part of the drawing. So
Right,
this would work for that portion.
okay,
But if you look first under import, file import, Civil 3D. Now, do you have that in your version?
yes,
Okay. And so you could look for just specific items, pipe networks, surfaces, labels, etc., or just choose all Civil 3D objects.
yep,
Now, and there's also another one other place under surface where you can import export surface. And there's that convert land desktop AEC, convert land desktop, see, land development desktop LDD, AEC contours, or convert land desktop LDT civil 3D surface drawing. That's really what we're after. This is the one that comes out of the cleanup bit, but I'm just pointing out this LDD versus LDT there. That's because, probably two different programmers wrote the command. They should, abbreviate those the same thing. It's the same product. But anyway, let's look first under import, Civil 3D, all Civil 3D objects. And so it wants to know a coordinate file to process in case it finds any Civil 3D points. All right, so because we opened the file, we did not have any coordinate file open. So we're just going to go here and choose new, and we'll call it roadway design base. We'll make sure we're in our location. We'll say open. All right, so we have now set that. And it's going to run through some things. And pull out everything that it can find. So now it says, okay, I found a surface called phase 6 original ground. Do we want to create a Carlson 10 surface? And you could answer these individually or whatever. I would just go ahead and say yes to all. And it wants to know the folder to put the surface files in. And I'm going to put that in. Hopefully it's right where we're working. Right there, that'll work for me. And I'll say, okay. Okay, so it's going ahead and finishing up looking for the rest of the Civil 3D type data. And see down here at the bottom, it converted one surface object to standard entities. So it took care of exploding that proxy object and replacing it with polylines for the contours. As you can see, we selected them, and all it is up here at the top in my properties, it's just a polyline. Okay.
did you turn anything on or off? After that process, because all I'm seeing right now is the alignment.
Really?
Yes.
No, I didn't look at your go to view, all on all layers, make sure they're all on,
Yep.
and you have nothing. If you select, just type SEL as a command and then type ALL, hit enter, and tell me up here, like if I do this, SEL,
Yep.
ALL, and then hit enter to finish, it should tell me up here in my properties how many it found.
2,459.
All right, so it found something, huh? You zoom extents, do you?
Oh. All right. So, yeah, that's kind of odd. So the surface information is, or the contours are still in there, but it's like they're at completely different coordinates now than than it was previously. I'm gonna close the drawing without saving and reopen it and see if.
Yeah, try that again and let me know what happened. In fact, I'm gonna stop my share. I'm gonna let you share
Okay.
and show me that.
So I'm doing roadway design base, right?
Yeah,
Open, continue.
uh-huh.
All right, so it's back to the compiled version, file, import, Civil 3D, all custom objects, right?
Yeah,
Okay. So then new coordinate system, overwrite.
yeah, that's fine.
Yes to all.
Okay.
Just gonna put it in that same folder.
Mhm.
So when I zoom extents now, whoops, not zebra. That's weird. Yeah, so that's what happened. So now that alignment is over here and the surface information came down here.
All right, let me take a look at something here real quick.
Oh, maybe that's why.
What was that?
There's no coordinate system set.
Yeah, I don't think there is in mine either. Let me see.
Okay.
Yeah, mine just says none. All right, so if I look at, see, these are coordinates of 3,000 and then 200 in the Y, 3,000 in the X, 200 in the Y. And whereas mine are, yeah, like 1,030,000 to 765.63. So this is maintained coordinates from what this originated. But again, my drawing setup, I've got coordinate system is local with no projection. Yours is local, no projection. It's exactly the same. Then you got US feet. Me. Let's see. Let's try this. Let me see, unit scaling inserted database. One block deleted. Let me turn that off a minute. And let's open. No, it did not ask me for, so what are my coordinates? See, now I'm at the proper coordinates. Huh. See what that does. One surface. And it's converted 0 points. Okay, so that's fine. Exit that. Yeah, it did the very same thing. Wow, if that's not strange.
I wonder. Try. So this is a. No, it's not. Never mind.
What was your thought?
I was. It's not a block, so it doesn't really matter.
It behaved like one.
It's almost like I was thinking maybe it's behaving almost like a block that has a larger scale applied to it, so it drops into the right place.
Yeah, that's what I was thinking toward myself. Let's see if I open Roadway Design Base. Let me take a peek here. All right, now let me look at. No, all it is that warning. It did not ask me whether I wanted to show proxy objects. Do you do you know whether you have object enablers loaded? You probably do. I'm sure.
I know in the hang on one second. What's the command? There's a command or a property that you can turn on where it prompts you
Oh yeah,
anytime it opens a file that has proxy objects.
yeah.
It,
And
I
that,
had that turned off because I got tired of having to click ignore, but
right. I'm not sure.
display maybe.
It's in
Oh,
here.
there you go.
Show proxy graphics as opposed.
Turn on.
So that was on object detect. Well, that's the thing. Yeah, see that all's fine. That's really fine. I'm curious about why this would have happened. Let's see. If we can't we can't figure this out, I'm going to let's go from not finding the endpoint. I'm going to try to just get something done that we can. Let's see what your insertion base is here. That's fine. Explode this.
Sorry to derail from what we're actually trying to do.
Well, no, but I mean, that's because that's a very big part of your workflow. We need to get that figured out. Some kind of setting. If I look at,
I mean, I don't know if like, would drawing units or insertion units have any impact on this?
That may be, that's what I want to see, because if you're set to inches instead, but take a look. Yeah, see, it's unitless, that's fine. That's what it should be. If I look at mine real quick. Yeah, it's unitless. Besides, that stores with the drawing anyway, so that should be, you're opening the same drawing I'm opening. All right. Something about when it blows that up. So that's there. We got our own world coordinate system. Try setting those factors are one. Import. Let's do the surface. And now, if I draw that surface boundary, I wonder if it put the surface in the right place, but just drew the other objects in the wrong place. Let's take a look. If I draw the surface boundary,
Scroll.
right there, phase 6 original.
Okay.
So the surface is in the right place. It just draws those polylines in the wrong place.
That's kind of odd.
That's very odd. And I've never seen that happen. I'm curious about something. If it is, I'm going to take this and move it nearby. I just want to make sure it is, I suspect it's scaling.
Yep.
Yeah, sure enough.
Very weird.
So if that is scaling, and it looked to be, you know, foot to inches instead of metric to English. So let's see what I do. No, it's even more than that, because that, I just scaled it up 12 times.
So it's
And
not,
still,
not feet to inches.
yeah, but meters to feet or feet to meters would only be about, 3.4808.
Right.
So it's not in those known options. Let's see. If it's not going to be the end of the day, it's not going to be the end of the world, because we've got the surface. That's really all that we had, and
Yeah.
and this other thing. But why on earth, if we say, see, what is our current weight? An inch to 40, that's our annotation scale. That's fine. All right, so you don't have scale when your insertion commands set to anything in particular other than one, but it's not, it's freeform set. Oh, come on. Wow, it takes a long time. All right, now let's see. Well, nothing indicated from that. Zoom extents. All right, well, let's move ahead. I don't know what caused that, but let's go ahead and just, for reference sakes, we will triangulate or contour from our tin file. Oh, and I think these are 5, but let me see. So that's on C topo major and minor. And that is an elevation of 100, elevation of 95. Yeah, so they're 5. We'll topo minor. C topo. Sure. And highlight depression. Get major, minor, spot label. Yeah, apparently they just did it with a line style. Okay, that's fine. We won't do those. Alrighty, and bada bing, bada boom. Off we go, and there they are. So you've got everything that you need here. You've got, you know, weird things like that. That's a single contour, and it has that
That crossing.
thing. Yeah, same thing there. So all I would do with that, and again, remember, anytime you go to draw the contours from that surface, you're still going to get that because of the way the triangles were formed.
Yep.
But you could just simply take out this segment. And so now you've got this one by itself and this one by itself. And that one by itself. So these two need to be joined back up if you wanted to keep them
Together, which we probably do.
I mean, if you wanted to keep them as a contiguous line, yeah, you do it like that. So then same thing here, we'll get rid of that one. It's in there twice. So now there's that. And so that one split from that one, we will join nearest. Let's just make it one here, link that one to that one. And I think that one's okay. Yeah. All right. So anyway, and we're really only going to use those for visual reference. In fact, you might even want to label them, which I did not do it when I said contour from tin file. However, you can generate the labels
Yep.
on there as well. So, but we'll see. I usually just point to them and read them. All right, so let me stop the remote and stop the share. I'll come back to the share. It's very odd. I've not ever experienced that in even way earlier versions. It could be something in your particular configuration, or it could be something in that particular version of AutoCAD combined with 2020 Carlson. Like, what version of AutoCAD are you using? Also 2020?
I think we may have. Let me see.
Just go up to your help system and choose about AutoCAD.
Oops.
And it'll say that very first line outside of the box, it says product version.
Yeah, we're using 2020.
Okay, well, that's pretty standard. I mean, you could, what would potentially be a problem is if you're running Carlson 2020 on AutoCAD 2022, for instance.
Right.
You know, that could be a problem. But people don't tend to do that if you've been running 2020 since 2020 came out. AutoCAD 2022 wasn't out yet then either. So anyway, well, without troubling it too much further.
Sure.
Now, I've got, I still have all of these goofy little thing. They're 3D faces, okay, and they're left over from that drawn surface when it exploded this block and left it in place. And I've also got, you know, this doodad here. Interesting. I removed polyline segment. There we go. Yeah, see, it recreated these differently. There's something afoot, whatever it is, I couldn't tell you. You know, and again, you could, you know, rid of that. Yeah, so, but, you know, our job here is not to make a pretty map, let's just move ahead. But I do have these things that I don't need, and they're just hogging up my drawing, these 3D faces. So I'll select one of those. I'll select similar and just get rid of them. Okay. Come back to my plan view. And now I have a design base that I'm using for visual reference, the drawn contours. And I've got a guide for my alignment. Okay. So the first thing to do in doing this road design is to generate a center line. And there's several ways we can do that. You might imagine they're all on the center line menu. And you can do it, you can design a center line and where it's going to prompt you for the stuff and you're going to put all the different things in as you go. But the easiest way to do it is to have it drawn in the drawing already. And then you would choose polyline to centerline file, and that converts it into that file. It also links up the linking if you have that turned on. Okay.
Yep.
And again, like the surface, once you have the centerline file, it will, you know, you could take it out of this drawing and recreate it anytime you want. Okay. So let's go ahead and choose that polyline to centerline file. And we'll just call this one, call it main. Second, before you do that, let me take a peek at something. Because I've got some things in here. There's Main Street. Yeah, I think these are already, done. I put some files in there that are already finished.
Yep.
If I draw Main Street, and if I draw side street, yeah, see there's Main Street, which was basically that same.
It's just the final version of.
Yeah, yeah. So I'm going to go ahead and take those out. I'm going to rename. I'll use that name and write over top of it so it doesn't. Or I'll call it. Well, I'll name them something else because those may go along. There's some things if you want to load this up, for instance, if you want to load up road design base 01. Let's see, RoadNet. See what RoadNet looks like. Yeah, see, they may be used for this. So I'll change the name as we step through these. So
Sure.
These are those other options. So I'll leave them alone for now. All right, so let's do centerline, polyline to centerline file. And we're going to call this one let's call it Baker Street. How about that? Select the polyline that represents the center line. And it says it should have been drawn in the right direction. It's correct. I don't need to do anything else at this point. Take my beginning station. You can type in a specific station or leave it at 0 is fine. Press enter to continue. So now I have, if I double click that, you see I've got it actually as an alignment file, as a centerline file. So we can put some curves in here as part of that editing, or we could have filleted this thing, the polyline, before. So if it had curves in it, it would also, you know, recognize those curves. So you can put those in there at any point. And, you know, it depends if it's not a road, if it's a sewer alignment, of course, you don't want curves in it necessarily. So let's just double click that and we'll get into our centerline editor. And let's make sure we're on that first segment, and let's choose fit curve down at the bottom. And let's give this, see, I don't know what kind of size we're. Let's look at our horizontal speed tables. We're going to set this for a design speed of say 40. And let's see, there's 4% max super elevation. Let's use, yeah, let's keep that. I'll keep her. No, let's go up to an 8%. So design speed of 40. Wow, see, yeah, those are really flat files or flat curves. So you need a minimum radius of almost a mile. That's ridiculous. All right. Close that. Let's just make this whatever. Let's try 300 feet. And say, okay. So that now has put that one in there. I'll go to this one, and instead of a 300-foot curve radius in here, I'm going to make this one a 100-foot curve radius. So I make sure that one's highlighted. I select that line, I choose fit curve, and let's put a 100-foot radius in and see what that gives us. And it's a little bit, let's change that curve. I'm going to double click that curve. I'm going to make it a little bigger. I'll make it 200 foot, and I'm going to hold the PI so that I don't shift my tangents. And that, all right, that's a little bit better. I'll save and exit. And now, let's see, I did shift it after all.
Whoop.
All right, I'm gonna undo that. Add fit curve, 300-foot radius. Here, fit curve, 200 foot. So this is fitting it, so it should fit it between. There we go. So it kept it there. That's all. And there's no real need. I just didn't want to be working on part of my alignment off my surface. That's part of the problem. All right, so I now have that center line. I can draw it any way I want to draw it. You know, different layers. I can station it. In fact, let's go ahead and do that. Just for yucks, we're going to go down the center line menu, station the polyline center line. And I'm going to go down here and choose load settings. Let's see if they've got any. There's some Virginia settings, but of course don't have any for that particular command. Settings. Well, let's see what you have this one. If you just look under settings, do you have CSWCL?
Yes.
All right, that's Carlson Software Centerline. Let's see what that looks like. Let's say okay. And now we'll choose their alignment. That was Baker Street. And there you see I've got my stationing. Along here, I've got my PC, which is sort of, I don't really need it labeled here. I can take that off. It's on here, same as there. And now you don't have to go through here and take these on and off. You can set that in the in the settings as to how it labels those. I just didn't want to get too cluttered. All right.
Yeah.
So now There they are, and remember they're linked, so if you move that, it will recompute and redraw the stationing. And let's look real quick. I'm not going to spend a lot of time on this, but when you station the polyline and the center line, there's all kinds of options in here. You know, how far apart are your stations, your intermediates, whether you do even stations, odd stations, start and stop, user defined, like if you have a particular station you want to label, whether you draw and label the PI stations, and then you got these label setups, which you'll set the text size and offset.
Default layer.
Yeah, whether it's parallel or perpendicular to the alignment, this is parallel on the left. What station types, all that kind of stuff. Markers, those are those circles for the PCs and PTs and the little ticks. And then the PC spiral setup, these are the circle markers for the PC and PTs. And if we had spirals, you would have, you know, tangent to spiral, spiral to curve, curve to spiral, spiral to tangent labels. But these are those lines that you saw, you know, from the PC. And it says label the PCPT, and right here where it says both, that's why it labeled it both on the alignment and on the line. But if you say just label on the radial lines instead, then if I do that again and have it recreate, it doesn't put it out here. So I don't have to go through and erase them out there. That's only going to put them here. Okay. So anyway, play with those as you see, and there'll be, you know, different needs for different features. Now, how familiar are you? I don't want to spend a lot of our time necessarily, you know, doing, I mean, unless you need it to show you how to tie all this with a profile and a template. Are you comfortable doing those at all yet?
Yeah.
All right, so the key that I want to show you before we get into RoadNet itself is this, that when you build a road, it's got center lines, it's got profile, and it has templates, which are under, well, these are our cross sections itself, but then under the roads menus where you talk your templates and template transitions and all kinds of different things you can do with it. And then you would put all those things together individually, and you could choose this process road design. This is sort of like a one-dimensional road net.
Yep.
And so when you bring that up, this is where you tag up all your files, and this is where you edit the files. And when you choose that to edit this file, like edit that center line, I just click edit, and you see I'm in that center line editor. That's just like if I had gone to the menu and chosen the file individually. Okay.
Right.
So let's, as long as you understand all that, and now Road Network basically does this same thing, but it allows you to have a network of potentially intersecting roads. Now,
Right.
you don't have to have, you can still do Road Network and do just a single road. In fact, let's maybe go ahead and do that here. So if we go to roads and go to Road Network, and we'll go to new, and we'll call this one Bakersfield. That's where we had Baker Street was our road. All right, so now I've got my little controls over here with roads, intersection, cul-de-sacs. Haven't added anything to it yet. So I'm going to first add, and that's where it tells you the existing surface is not set. Okay, so that's why you have to set that surface, whether you use it or not. Okay, so I'm going to look for that phase 6 original ground. Open that. And now how do I want to add the road? If I say centerline file, I can just choose the file. I can screen pick a polyline, at which point it would then go and create a centerline file for me. So I'm just going to, I'll choose the centerline file, there's Baker Street. And it now wants to know a design profile. Well, I don't have it made yet, but I'll go ahead and just take the file name. So Baker Street CL, Baker Street.pro.
Yep.
No template, but I have some files that have already been filled out in my processing here. All right, so now I will say oops, oh, crap. Sorry. We'll go ahead and choose Baker Street. And okay. Error missing template. All right, I know that. So if I choose a design template, let's choose a new one, and we'll just call it 2-lane with, let's call it 2-lane, no curves. All right, now if I say this, it's okay. So it has allowed that to be part of the definition. I haven't filled out any of that data yet, so it won't process yet. Now, and tell me how familiar are you with all of this stuff? Again, I don't want to.
So I can do basic, basically what we're doing right now is like adding the center line, adding the profile and stuff like that. I haven't dove in too much to intersecting roads, but I've gotten some exposure to it.
Oh, okay. All right.
So I don't know, maybe half familiar with what we're doing.
Okay. But I mean, you understand the process of road design as an engineer, so you'd be surprised how many people take this class and they don't know the first thing about design.
Yes.
But anyway.
Yeah, like I've played around with the template editor and like creating the cross section.
Okay.
A little bit.
All right. Well, let's step you through some of those to give you a little more exposure to that, so you can see what's up with it. First of all, so right now we've defined our network of roads. It only has a single road in it. Now you don't add intersections. You can only add roads and you can only add cul-de-sacs. Intersections are found when center lines actually intersect. They can either
see that there's multiple center lines, right?
Yeah, you can have multiple center lines, and if they touch, that means they intersect, whether it's in a T or if it goes across like a four-way or whatever, then that's what defines those as intersections. Now, so we're going to fill out a bunch of things, but let's take a look at the settings as to what controls this whole process. So I'm going to choose my little gear icon up here, and we're going to talk about these as briefly, but yet as in-depth as we need. Tabs across the top, processing options, existing surface. Now there's that phase 6 original ground that it prompted me for before. I could change that to a different one if I needed to. I could have a rock surface that's underneath that, so it knows when it's getting into over excavations. But now here I've got my station interval. And this is, in terms of template-based road design, this is the interval for your template drop. How often down that alignment do you want to drop that template to start creating this road? And if you got a really tightly turned road or something that has a lot of really finely changing terrain real quickly in short distances, you want to make that tighter. But you could get by with that even say at a 50-foot. And then say, as you go through the intersection, because you want to tighten up that modeling a little better through the intersection, you make it smaller than that. So I'm going to say drop a template every 50 feet and tighten it up as you go through intersections. Any particular special stations that you want to process, if you have any of the centerline stations, that means when you get to a PC or a PT, you're going to always drop a template at those, even if they're not on that interval. Same thing with the profiles. If you have a start and stop of a vertical curve, you want to put templates there as well. Any kind of super elevation that you may have put in, and any template transition. So if you transition from a 2-lane with no curves to a 3-lane out here on the end because you're putting the turning lane in, then you want to make sure that you drop the template at the start and stop of those transitions, even if they're not on that interval. Okay, if you don't have those on, you'll get a little stair step in your shape of your road, because it looks at it back here, it goes past that special place and puts the next one down up here when it's got a different definition. So
Yeah,
that's why you want to have that kind of thing done. Okay.
got it.
Now, slope this time perpendicular to, now here we talked about before the slope direction or the polyline where we're doing the slope or the design pads.
Yeah,
But here's where we want to make our slope, and you can choose either one, but we'll keep it as center line because we think of road design as that crown slope. That's what governs what we do. So we're going to keep that there. And then we're going to check on tie to existing, because we want the outside edges of the road to then tie into the existing grade.
Yep.
You don't have to do that. In fact, and you can also turn it on and off at various station ranges. So let's say you're going along, you're tying to grade, but then you get to a bridge. Well, you don't want to tie your sides of your bridge down to existing ground. You can turn that tie function off between certain station values. Okay, so that's what you would do in the actual processing part. But in general, we do want to tie to the existing grade.
Right.
We also,
You said specifying stations for tying to existing is done through the actual processing. Like, so
if we want to put any gaps in it, yes, that's where it's done.
okay, all right.
Yeah, I'll show you. It's a button in the dialogue, that big screen that pops up.
Yeah.
So I'll show you that in a minute.
Okay.
So as a default setting, we're tied to existing. We will process our intersections and we will connect our roads. So if we have a road that comes up, across here and then goes another one across there, it will connect the two together.
Got it.
I'm going to come back to output options in just a minute. I'm going to look at report options, and let's go to I'll cut my report precision down to the nearest 100th. Report cut and fill end areas, cut and fill differences, shrink and swell factors if you wanted. Subgrade topsoil areas, again, if you had those like topsoil strippings, if you had those other surfaces, and the cumulative cut and fill. As you're going along, you can have it report that as well, so different options you can do for that. Display options. And that means when I'm in here and I'm choosing this, I can tell it to, if I check this and if I click a particular center line or a cul-de-sac or something, it's going to go over here and automatically zoom around that feature if I have it on. Or you can say, how do you want to highlight the thing you have selected? You can either thicken it or dash it or nothing. So I like to thicken it. I see it pretty quickly there. And if you have an intersection or a cul-de-sac, how do you want to show that? And it shows it as a circle, like a target,
Right.
As opposed to an arrow. Okay, so that's just a marker. All right, go to my defaults. Now here's some things, and again, these are all defaults that can be overridden at process time at individual intersections. But in general, we're going to say use a 25-foot intersection radius, and that is the return radius on the intersection. Let me see if I can find something already drawn. Well, it's drawn obliquely, so it'd be hard to see. Anyway, that is this
Yep.
when it says that, that's the edge of pavement almost always. It's not necessarily always, but it's almost always the edge of pavement. And that's that intersection radius. So that's the returns in each of those four corners if we have a four-way intersection. Okay. And now the center line intersections, when a center line intersects another intersection in profile, it has to go across there and make a vertical curve.
Right.
And when you run this process, you're going to tell it which is the main road, and you typically will hold the crown on the main road, but the side road, you're going to allow it to put in these little transition vertical curves to get from where it is to approaching that 2% upslope pavement, and then the 2% downslope pavement, and then come back out of those. It transitions with these vertical curves. And so these are distances that you can put in there, and I'm going to put in like 15 feet. And then from my PVI distance, I'm going to call that one, say 30 feet. And that is the distance, if you're looking at it in profile on a side street, that's the distance that the PVI of that transition vertical curve is away from the crown of the road or the point of intersection there. Okay. And again, just defaults, and it will adjust those if it needs, and you will, and you can override them. Now, surface method, profile method, and transition method. Again, here's where you decide whether you're going to hold the main crown or you're going to splay the surface radially from the curbs or the edge of pavement. Excuse me. Typically, like I said, if we have a main road, you're going to hold the main crown. If you don't, if they're equally the same, you might choose that radial from curb. The profile method means, again, what we're talking about up here with these vertical curve lengths, if I say allow a single PVI, then it won't use those, it won't generate those little small transition curves. But you could have it do, I mean, it only basically is the point of intersection. When you cross the crown of the road, that's that single PVI for that crossing street. But if you allow it to do PVIs for the incoming and outgoing grades, that will do those transitions. Okay. And now the transition method across intersection or the intersection midpoint, that has to do with, let me see if there's a picture of it here. It's probably going to be too far to try to dig it out. Maybe not. Let's see. It's a really impressive help section, this one, by the way. Import display default. Here's my default. Yeah, here's how it makes the surface radial from curb or hold the main crown. So I don't know that you can really tell much from that, the way they're doing it, but
Yep.
yeah, radial from, oh, I see, radial from curb. You see what happens is that this edge on my main road, if it's radial from curb, it turns off that edge and it goes radial from the curb out all the way across the intersection, and then it goes back to picking up that edge. If you say hold the main crown, that edge gets maintained, and this comes down to it, and there's a little crease in it as you cross, or it could be a crease. It's, it's often not a crease. Now here's the transition method, what I was looking for. It's when a road has a varying width that goes through an intersection. And the across intersection looks at the primary road from the start, and let's say like this example here, from the start to the end of the intersection, and it finds the maximum offset between the center line and the edge of pavement and uses that to set the edge of the pavement break line across the intersection with the secondary road. The midpoint option finds the pavement width at the intersection station and uses that distance to set the edge of pavement break line all the way across the intersection. Yeah. That's basically if your main road is not a constant width, it's either going to take the maximum offset or it's going to take the average offset. It's really kind of confusing, but in any case, we'll take it across the intersection and our roads won't actually flare into the intersection or through the intersection. Now, cul-de-sacs, if we do our cul-de-sac direction, left to right or right to left, that means when we do this alignment is coming this direction, okay? Coming around this way. And so it hits here. And if we put a cul-de-sac out here, the road's edges are going to come up, and then when so it gets up there even with that point and starts the cul-de-sac, it then is going to wrap it around. It's either going to go right to left or left to right as it computes the edges of the cul-de-sac. And that has to do with, because you can look at the profile of that cul-de-sac edge, and that's where the zero station is and the ending station, basically the direction that gets drawn. So it's really just a matter of preference. Okay. Different styles of cul-de-sac, standard, teardrop, or straight. I'll leave it at that. A cul-de-sac radius, I'm going to put a 65, and let's put a radius of 30. Now let's make it 25 also. Yeah, and let's see. Yeah, let's make it 25. And then you could adjust it to an offset with a teardrop setback, and right in here is the vertical curve length, and I'm going to call that 35. Now what this vertical curve length is the vertical curve around the cul-de-sac edge. So like I said, it creates a vertical curve if you wanted to, as the edge of pavement walks around that cul-de-sac. Now, what's that useful for is that you can manually edit that profile to say, pull down a low spot somewhere along that edge of pavement. So instead of just falling off radially from the point of that ending alignment, you can pull down a low spot and make that a place where you put an inlet. Or you can pull up a high spot so that it sheds water back down into the main street. You know, any kind of way that you can do that. Now, road design parameters, all that does is it sets up it lets you use a file that checks for things, much like those curve speed tables and all of that. So
setting like design minimums or maximums.
Exactly. And it'll be like, and not just geometrically, I forget everything else.
It's kind of like with this sewer network stuff where you can set, all right,
yeah.
if it's hitting crossings or not meeting a minimum depth requirement, or
Yeah, that's right. And it basically what it does is it flags any conflicts. It doesn't prevent it from happening. Okay, but that's how that works. All right. So now let's come back to these output options. Up at the top, we choose that. And you can choose to triangulate and contour. And right now it says no output, but it would draw the contours and all that. I'm going to go ahead and triangulate and contour, and I'm going to hit setup, but I'm going to make a new, and see this commit, this thing should look familiar to you now, right? And so on the triangulate tab, now it's a little bit different. I'm going to write the triangulation file, and I'm going to go ahead and select that, and I'm going to call it just roadway. Okay, so now that's going to use roadway. It's going to make a 10 file called roadway. Now, if you go to your contour tab, draw the contours. I'm going to call this one I really should put these on C-topo dash. Well, I'll put them on C-road dash. Minor, 5 foot, draw index, C-road dash major. No smoothing. Don't need to worry about that. Contour by interval. And by the way, when you're doing your contouring and you're looking at surfaces, I don't know if you've noticed or paid attention, but you could, so we're almost always do contour by interval. You can also do contour a specific elevation. So like if you wanted to put a flood level elevation around a property or something like that, or you wanted to see, what's the 1850.5 elevation line around my property, you can have it do something like that as well with this switch right here. But so explore those when you get a chance. I'm not going to label anything there. I'm going to just go from these. That looks good. Back to my triangulate tab. Now here's something called set colors and layers, and this is where we can define these grade. You can do it by grade ID or by cut and fill depth or by specific layers. And we'll come back to this after we have a template defined that has points in it that give us our grade IDs, and we can set up different colors for the actual surface triangles themselves. Okay. So that should be all we need at this point. We'll say okay. And that's on that button. Merge the road with existing. I generally don't do that at this stage. You certainly can. What surface do you want to draw? I'm going to draw the top, the finished grade. You can do the subgrades, etc., in case you're needing to generate that to give to a contractor for machine control. And this right serve CE stakeout. And if your surveyors use Serve CE as their surveying data collector software, this will take the center line, the profile, the template definition, and puts all of that in the data collector, and it sets it up so that when they stake the road, they're basically processing the road as they go along, and then it figures out where they are on the ground and how much cut and fill and where those points are. So it's a real handy way to do that, to load that information in for them to stake the road. Not everybody uses that, so it doesn't necessarily matter, but that's a Carlson product. All right, so these other things that we're going to draw, this is everything that we're going to be outputting. Now, I'm not going to draw the template polylines. Those would be, as we drop a template, it basically goes down and draws the subgrade lines underneath the ground. I'm only going to be generating the top surface lines as myself. So I'm not going to draw these subgrades. I'm not going to hatch. There's all kinds of different things you can do with this. Label a profile if you want. Now, output coordinates is a nice little option here. And you can choose setup, and you could say, I'm going to select my file. Right now it's pointing to none. I'm going to select, what did we call that? We'll make a new one. We'll call that also Bakersfield. Let me check this minute. One quick second. That might be my guy with the car that's 2 hours late.
Yeah, no problem.
Yeah. Hello, it's Ken. Yeah, I can, but sorry, I'm in the middle of teaching a class. I got to go. Thanks. Bye. No, that was telemarketing. Oh, well. Looks like they've forgotten to bring my car to me. Well, we'll see when we get back. All right. So here's my Bakersfield file. And now at this point you choose based on the template. Now I don't have a template defined yet, so I've got center.
Right.
But if you have, you've got the, say, face of curb. And you say, all right, I want to output the face of curb points on either side of my center line. And if I choose draw points, it will draw them into the drawing. Otherwise, it just puts them in the CRD file.
So, I guess, can you only, if you select a specific template to output, is it only going to output that template, or can you select multiple?
Well, it could be multiple templates, but these are points within the template. So typically, even though you might have multiple roadway templates, you're going to typically always call the edge of pavement either something like EP or EOP.
Right.
Or EA for edge of asphalt, whatever you want to call it. As long as those names are the same, it's going to find those points. And if they don't exist, it will just not output them.
So I guess if you didn't choose a specific template, is it just going to output everything, or?
No, this template ID to output. That's not, you see, there's nothing in here because I haven't defined a template yet. It's not the name of a template to use. It is the point in the template that I want to output. Right now, the center is the only point I've got. You'll see that we'll come back to this and look at it when we define the template.
Oh, okay.
So, but what I like to do is I like to typically send out the face of curb on either side. I'll include the station, and I don't need the offset, just the station. And the stations I want to output, I'm not going to do all of these. I'm only going to do the low points along the profile, if I get it there. All right, so you get a sense of what I'm doing with this. I'm kicking out the edge of pavement or the face of curb or whatever, but only the low spots along the road. So that's going to generate point locations where I need to put my inlets, right?
I see. Okay.
Yeah. Now, you don't have to do that. You could do all of the main interval stations, and you can generate a list of points that the surveyors go out and stake out. So there's different uses.
I see.
Others,
So
right?
what we're doing right now in particular is just helping ourselves figure out where we need to put inlets.
Exactly. And
Okay.
you could also, put out the center ID and say, put the high points, the high stations as well. So, and you can have more than one in this list. So, and, but we'll see that once we have the template, we'll come back to it. Okay. So that's about all we need now. You can output the edge of pavement profiles. If you want, set that up, and that puts these, generates these as individual profile files. I'm not going to kick those out. I'll just leave this alone for now. And then you can finally elevate lots and pads. So if I were in a subdivision and this stuff processes, and if it changes, if I change the profile and it reprocesses, it's going to go along this alignment. It's going to look left and right. And as it sees property lines and or building pads, it's going to establish those elevations based on their relationship to the road. Okay. So it can get very, very complex if necessary. And then you got the set layers where you can set all of these different layers for the different drawn output file settings. I've got most of these are defaulted, I think. Output existing profile at left and right, I'm not going to worry about, but this is my existing profile file. We'll have a -ex on it. Cul-de-sac will have a CDS, intersection, etc., rock. Final existing of my cross-section files. Okay, so just I'm going to take those defaults. All right, I'm going to say okay. And now while I'm here, I'm going to choose the save icon so that I've saved that. And see, what else do we want to do? I don't know what this draw business is, but so I've got this, but I don't have, so if I click on that Baker Street, I still have some things I have to define. I've got to define this profile, and I've got to define a template, and that template can be a template or a template series. It can have transitions. It can be a grade table. Now, all of those different options, and we're not going to have time to run through all of the options, but that's where you see them in here. You've got a typical, standard template. Then you've got transitions, grade table, a series of different templates, then all your super elevation editors, etc., etc. Okay, so we're going to, at this point, for this single street, we're going to work on getting some output and see what happens with it when we have an intersection. So under our design center line, we've already got that. We see it. It's pretty well set up for us. And under my design profile now, I'm going to choose the edit button. Oh, by the way, up here's where you can restrict the station range that you want to process. If you got really long roads, you want to look at just a couple of things. And also the station gap settings. This is where I told you could turn off the cut and fill gaps.
Okay.
Like if you go across a bridge or something, that's where you add these in there. And they're just ranges of stations. So that is what I meant. It was in the processing. It's up here in these buttons. So now on my design profile, I'm going to choose edit, and this is going to go straight into my road profile. Under the profile menu, I've got design road profile. So this is going to be, it's going to put me into the road profile editor as opposed to the generic profile editor. And there's a couple of handy things about that here. Okay, and we see right now station 0 at an elevation of 80.8372, and it goes all the way out to station 1341.23 at 107.1894. But we need to take a look at it. We need to see what the existing ground looks like underneath it, which we don't have yet. Normally we would, but we need to go into our setup and fix that. So I'm going to hit my setup button down here below, and I'm going to say, all right, there's my reference center line. I'm going to show center line special stations just for yucks. Show the intersections, show sag and crest points. Now it's right here. Output the reference surface profile. That's the existing ground. You see that EX by default as the extension.
Yep.
So that's going to be done there. Now, when I come back into it, it'll show it. And then if I actually just pick up that center line and move it around on the ground, it will recut that profile automatically and, make it part of my design here. So, but my reference surface is not set here yet. So I'm going to choose the set button and choose that phase 6 original ground. So that normally is set. I must have missed checking it back on my defaults or something. All right, and now these down here is, how do you design it? When you're designing vertical curves, do you use K values or sight distance as your guide? Either one.
The couple of times I've done it recently, I've used the K value.
Okay. So that lets you do that. I'll tell you what, I tend to use sight distance simply because I can visualize that better.
Sure.
I know what a K value is, and if I'm working for an agency that limits me to a particular, then maybe I'll hold it to that. But so that's up to you as to how you want to do it.
Okay,
And then if you choose K value, this column in our spreadsheet over here will change, okay?
right,
And now drag a PVI options means if I drag these PVIs around graphically, what do I want to do? Hold the length of the curve or hold the K value or hold the sight distance so that it adjusts the length to still hold these two things constant, or I can hold the curve length the same regardless of what these things turn out to be. So, you know, you can choose that to your liking. All right, so I'm
right.
gonna say, okay. Now, so there now is my existing ground. The green triangles are those,
Special stations.
the PC, PT, PC, PT. And the reason you might want to show them here is if you're designing to AASHTO standards, you should not have any horizontal curves on the part of the profile that has a vertical curve. They should only be on vertical tangents
Right,
to keep from having the broken back visual situation. So now in this particular example, because this file is so horrible, it's not, you know, we're not going to be able to do a nice 5% roadway.
yeah,
You can see, but so right now we're starting at the start, we're going to the end, and it has a depth of 0 here. We go here and it's got a depth of essentially 0. I'm going to clear that out and make it exactly 0. So it targets the surface right there, 0 to 0. You can make it anything you want. And keep in mind, depth is depth. So 2 feet would be 2 feet under the surface. Minus 2 feet is a negative depth. And so that makes it 2 feet above the surface. All right.
okay,
If you
yep,
put those values in. All right.
yeah, so, because surface level is your datum. And, yeah, like you said, depth is depth. You're going
Yeah.
in a specific direction. If you do the opposite of that, you're going,
That's correct. All right.
okay,
So we now have just 2 points, and we need to add a PVI. And we're going to do all this stuff graphically. You can type them in down here, do anything you want. You may have the data to be able to do that, but I'm just going to graphically add. There's your plus that means to add, and then the pencil means to edit. So I'm going to click my plus, and I'm going to come up here and I say, I'm looking at this and I'm going to want to, you know, put a tangent up to here and then maybe climb up a little steeper in here. So I'm going to put like right in here, click. Now, when I click right there, it found the station. I can set the station and slope to snap to the nearest, say, 5-foot station. So it goes to 340, maybe nearest half-foot slope. But what it didn't do for me is to set the vertical curve length. So if I set that to be 200, then that gives me a sight distance of 495.82. Or you could, you know, put this in and say I needed 500 feet. It's not, let me take this. Yeah, there, 500 feet. That means I need a vertical curve of at least 208.36. So maybe I make that 225, just for round numbers. All right.
1 second, sorry, just curious why I'm not getting the same values as you. Oh, maybe because you did yours on sight distance and I'm doing mine on K value.
Could be. It could also be, it's depending on wherever you click it, because I could have clicked slightly higher than yours and yours slightly lower. So, but anyway, once you click that, you're going to get that PVI. Yeah, it's right entirely over that horizontal curve. So that's a bad design in terms of AASHTO. And then I'm going to say, I'm going to add another one, and I'm going to put it up here near this point in the middle. And let's make that, let's say I need another, say 350 feet up to short, let's say 150 feet. All right, so that's 257. Let's make it 250. That should work. And I'll say, okay, there. And so now there's that curve. I've got a curve here, and I come down to the end. And you can make these as many or as little as you want. Now, the graphic editing of these, if I grab my pencil, I just click near the PVI, and I press and drag and hold the mouse as I drag this around, you can see what I'm doing here. So you can lay it right on the existing ground right there if you need. In fact, you could probably see up there at the top, that's like a 9.8% slope. So if I come up here and let's maybe do that. So I stay on the ground. Instead of coming underneath it like this, I'm going to do that. So I may decide I even get to that second PVI that's marked with my X there because that's the line I'm in. I may decide to remove that PVI. So it's just a single curve up here at the moment. So I'll drag that down. I'll set that more on the ground, but that puts me really deep. I need to be a little bit balanced like so. And then maybe I'll add one here to sort of bring me down. A little flatter than coming off there. Now keep in mind too, this vertical exaggeration is fit. If I put it at 0.1, that's what my road really looks like.
So I have a question about vertical exaggeration.
Yep.
So the way it's set up, it's in Carlson, there's specific values that you can choose for the vertical exaggeration.
Are you talking about like if you plot a profile, you mean?
Yeah.
Okay.
So let's say, for example, like, industry standard for the vertical scale for a profile is generally what, 5 feet? For the vertical scale, and then
yeah, I mean, it depends on where you are. Some places it's like a 10-to-1 exaggeration, or some places it's a 4-to-1.
So my question would be, let's say, you don't have a nice, you're using a different horizontal scale, so you don't get a nice 5-to-1 exaggeration or 10-to-1 exaggeration. Let's say you have a 30-foot horizontal scale and a 5-foot vertical scale, so the exaggeration is like 6.
Yeah. So yeah, when you go to plot your profiles,
yeah,
you can set specific scale on each of those.
Okay, so it should.
Yeah, but what you're looking at here, this vertical exaggeration, that's just for this display.
Okay.
And that's all it's going to govern.
So when you're so I understand that part. When you're going to draw the profile, it brings up the little it brings up the display on the bottom half of the screen.
Yeah.
Like when you're actually drawing the profile, it'll like at the bottom of your screen, it'll bring up another like window, and you see a miniature version of what we're looking at right now. And you can kind of play with some of the exaggeration or those sort of things. I guess that's just for display purposes on screen. And then I guess once you step to the next window where you actually select the profile settings, you can set the specific vertical and horizontal scales there. Is that correct?
Yeah, it's like right now, it's purely visual. Here, it's only when I choose to draw the profile file.
Okay.
And that's where we set up the grid.
Yeah.
And so that's where it does all of that stuff.
Okay. Then that's fine. Yep.
All right. So now we've got a profile done, and you see part of the profile window up the top it shows you as you move the mouse around, it shows you the station, the elevation, the slope, and the depth, the value at that particular location. Now,
Yep.
Couple of other helpful things is like back here in my setup, if I chose to output left and right profiles, let's say, I've got two 12-foot lanes and I can do it like this. You see what I've got there that shows me on the existing ground, you know, what the edge of pavement might look like.
Right.
All right. So, or I could go 50 feet either side. Maybe I'm putting a ditch line over there. So there's all kinds of things that you can do with this that can be helpful. But for now, let's sort of stick to the basics and try to get through here with enough time to get things moving.
Yep.
So, so that's, you know, good enough fit visually. I can look at that just eyeballed. It looks pretty balanced. And I'll show you once we have a template, we'll come back into this. And you see down here where it says show sections.
Yes.
As long as their template is defined, it'll pop up another window and show the cross sections. And as I move this around, those cross sections will dynamically change themselves. And you can see not only that, but you'll also see up here in the words, you'll see the amount of cut and fill, and it'll show you a cumulative total. So when you get out to the end, you can tell if you're balanced or not just by running this editor. Okay, so a lot of times you can't really get the balance because you've got other constraints. You know, there's a reason you've got other things in place. All right, so we'll take that, we will save, and we will exit. Now we've got two parts that we need, the center line and the profile. We have named our template. We haven't built it yet. We want 2 lanes, no curbs, and let's choose edit. Now you may have slightly different buttons. I think they keep changing the pictures of the buttons to try to be cool. But if you're familiar with this, what you basically do, right side same as left, we'll stick with that for now. It doesn't have to be, it can be asymmetric. Or your point of reference, what it calls center, might be the rightmost edge of the roadway, and everything else is defined to the left of it. You know, different things, what they call the profile grade line. Yeah. PGL. All right, so we're going to take a look at what this will do for it, and we're not going to have it, you know, like we also do an advanced road design class that's like 2 days of nothing but this really complex roadway template editing and transitions and stuff. So, you know, you're trying to get all of civil in 2 days. So, but anyway, so what we want to do, let's start building our cross section. We're going to stay, because it is checked same as left, this right-hand side grayed out. Because I have up here, my left side is going to display fill, my right side is going to display cut. And again, that's just for display purposes. It creates a cut and fill based on where it is on the ground. It's just for what I'm looking at as to what it shows. Yeah. So now I'm going to hit my grade button. And I'm going to do this first grade. So I'm going to start at the center line of my crown, and I'm going to put a slope of a percent of -2%. I'll keep it linear. Some places like out in California, I think maybe uses parabolic cross slopes of the roadways. It's really goofy. Don't worry about it at this point. Look it up later. And I'm going to make 12-foot lanes. So I'm going to go 12 feet. You can pick. And now I'm going to give this an ID. This is going to be my EP, my edge of pavement. There's also a set button, but there's nothing to select because I don't have my template ID library built yet. And you can do that off of this roads menu, and you can have a list of names as to what they refer to, so that that helps you keep that consistent among all your different templates.
Basically, so you're creating a lot similar to the library of like blocks and symbols. You're just creating a library of preset road template elements.
Of road template names in other words, I'm going to say I built a little library that says EP. Well, I may come in and say, well, what do you guys call your edge of pavement? Do you use EP or EOP or
Okay.
EDGE, you know, whatever you choose. And it just helps me stay consistent with that. But
Okay.
so this is the key to all of this stuff, is to give these things names that you can refer to later. So I'll say, okay, so now right here, I have built from the center line out, the center is the center. This one grade is my EP. That is where I am right there on the edge of that 12 feet away, 2% down.
Right.
Now I'm going to put a shoulder on that. And that's another grade. And this time, instead of a 2%, I'm going to put a -6%. And I'm going to make that 4 feet wide. And I'm going to call that SHLD. Whoops, I got to actually type the S for shoulder. Okay. I'll say, okay, so now there's my shoulder, there's my edge of pavement. And you can move these up and down so that, you know, you can build some pretty complex things. But now I've got that as my edge of pavement. Now, if I put just after my shoulder, let's say I go straight to cut, and I'm just going to say a generic 3:1, and my fill, I'm going to say 3:1. And that basically is a road, comes across at the edge of pavement, has a shoulder, and it goes immediately to cut and fill. But it doesn't have to. You could say, come up here after shoulder, and let's put a little buffer strip, and we're going to build a sidewalk in it. And let's see, we're going to go grade again, and we'll make that one, let's say a +2%. And we'll just take that over 4 feet, and we'll call that SW1. All right, so I'm coming up, so I'm going to have a, see, that's 4 feet. So it's just a little positive drain down into that little, that makes it a channel. Maybe I want to, I'm not sure I want to channelize my flow right here. Let me figure out something different to do here a minute. Come down off of that. Let's take that one out. So we're just coming off of the shoulder. All right, so let's put some ditches and berms in here. We do that on the cut and fill buttons. So on the fill, down at the bottom, we can say use a berm. And we say only put a berm there if your depth of fill is 10 feet or greater. So if it's less than, well, let's make it 5 feet. So anything less than 5 feet, it's not going to put a berm. Anything over 5 feet, it will. And then down here, you just start building the grades. So we add a berm, and we're going to go at a ratio now of 1:1. And let's make it a foot, and we'll call this one BRM 1. We'll add another one at a 0%, again for a foot. We'll call that BRM 2. And that could be all we did. We could come back down before, but we'll leave it like that and we'll say, okay. And so now you see I come up and I come across, and there's my berm for my fill slope. But that only happens if it's over 5 feet high. Same thing in my ditch here. Right now, I've got a natural ditch just at the edge of this and the edge of my fill, but I could put in under cut, I could use a ditch where I would say, only if I'm over, say, 10 feet deep, I'll, well, let's again put it 5 feet deep, and I'm going to add a ditch, let's see, add a ditch at -1 to 1 for a foot. We'll call that one DTCH1. And then we're going to go across and put a flat bottom on it, 0% for a foot, and call that one DTCH2. And we'll say okay. And so now, if it's over 5 feet of cut, I'm going to say I'm going to need a little bit more water carrying capacity than just where the shoulder ends against the cut bank. So it's going to spill over into a ditch like this. All right. So all kinds of things we can do. Now, all we've done at this point is have the top surfaces.
Right.
All right. And you can go ahead and, you could hit save, and you can go ahead and process that and it would work, but you wouldn't get any of the subgrade information. So we're going to go back now and do the subgrades. So I'm going to come here to subgrade, and I'm going to, again, we're starting at the top and working our way down. So we're going to match our surface slope, and we're going to intersect the surface. We will say, well, we'll leave it at straight up at this point. And the horizontal offset, if we want to go 12 feet, and then we had that 6 foot shoulder, that's 18 feet, we could type in 18 feet if we wanted to, or we can go to 12 feet, we could type in the 12 feet. But here's another nice thing about this. Well, first of all, the horizontal offset is how far away from the center line do we want to be? So that's going to stay at blank or 0. But it's this distance that we could either type 12, but that means it's always 12. But if we hit select, we use one of these named points, then if that EP should ever vary as it goes along the alignment, either through a template transition or any kind of a template centerline diversion, then it will follow that EP. And you could even do things like EP plus 2, add 2 more feet beyond whatever EP is at that given point. All right, so we'll leave it at EP at this point. You can call that, let's see, what is this going to be? Our ID to what do you call your top course of asphalt?
SM.
All right. We'll call it SM. Now we need to give a vertical offset. How deep is it from the top? And we over here change our units to inches typically.
Yeah, about 1.5.
So we'll call that 1.5 inches at the end, and there it is. And we say, okay. And so now it goes out there and comes up. That's the end. That's my pavement. Okay. So I'm going to do another subgrade. And this time I'm going to do, I'll also keep it there from the center. So what's next under my pavement?
Your intermediate course,
And you call that what?
IM.
So we'll call that IM. Now you could actually put, the name of the material like asphalt or whatever, but you see what you're doing here.
Yep.
No horizontal offset, also straight up. Now the vertical distance, how thick is that layer?
3 inches.
All right, so it's 3 inches, but it's 3 inches plus the 1.5 inches above it.
Right.
So you have to do 4.5. Okay.
Okay.
And it's going to go out to also EP. So there now you've got that. And then maybe we're going to put one more of stone or aggregate or, number 57, whatever you call it.
Yep.
And this time it's going to go EP plus well, our shoulder is 6 feet. Let's take it to 7 feet, or we could have typed shoulder plus 1. But this way, if the shoulder disappears, we're still going to tag the EP. And we'll go out here and now what happened? Oh, I didn't get the depth right. So I come back to that stone. And maybe that's 8 inches of stone, whether it's 8 and 4.5, so that's 12.5
Right.
here, so 12.5. All right, so now there it is, and you see it comes down here at that slope of the pavement, and then it changes slope to match that shoulder.
Yep.
Because we told it to follow the slope. If we had instead said to special, we could have given it a particular slope and made it, just say -2%, and that way it's going to taper. It stays at that 2% and it tapers. It's thinner here than here. Okay. Now we've gone a foot beyond. Shoulder to 12 and 6. Oh, I'm sorry, that's a 4 foot, not a 6 foot. I looked at that 6, it's 4 foot. So that should be 5. All right, so now it goes out and it comes up and it hits the top of that berm. So that's probably even still a little too much. Maybe we would do it right at
The shoulder.
shoulder. So SHL. I think is what we called it. But yeah.
Oh.
And again, now, whoops, what happened there?
So it's only doing it the distance of the shoulder itself. So it would have to be EP plus shoulder, right?
No, it shouldn't.
EP plus 4.
Yeah, it should go out and find the shoulder point. So we do EP, of course, it finds the.
What if we did at the horizontal offset?
Well, that's where it starts. It's going to start at 0 offset.
Oh, okay, okay, got it.
And so now, yeah, see this. Let's say if I went out to berm 1, for instance. It doesn't even find it because it's not on both sides. That's the problem. It should be able to do that. That's they've blown it up again. All right, so let's change that to EP plus 4. And then that goes out to the edge of that. Okay. All right, so that'll give us our subgrades. So this is stone all the way from the shoulder down and underneath the 2 intermediate and top course here.
Yep.
All right. Now you could also, instead of go straight up, if you said continue slope, then it goes out to, what happened? It's not. Yeah, continuous slope, it should go out until it hits something else. I guess there's nothing else beyond it other than this. If there's other features out here, it will continue to hit another subgrade or something like that. So that's fine. All right, so for now, let's save this and we'll come back and we'll add some curbs to it here the next go around. And but let's go ahead and process this. We'll save and exit. And let's just go ahead and hit OK. And it says my template 2-lane no curbs has changed to what a process road network. Yes, and that's because I've got a prompt set. It's an existing surface not set. Why does it keep losing that? All right.
The computer knows it's Friday as well and wants to end the day.
Existing surface. Right there it is. All right, and I'm going to tell it here to tie to existing. The profile's still good. Oops, sorry, I meant to do the template. There's that. Processing is on. There it is. Yeah, I just didn't do it last time. All right. So I'm gonna set some colors here so we can see things. C-road. What did I call that? Major and minor. So we'll make these red. We'll make these sort of orangish. Yeah, that's too close to minor. Let's make that sort of blue looking. There we go. All right, so that brought that in. And you see here where the ditch starts or the berm starts and stops because it's not got enough fill in there, okay?
Yes.
And I can take a look at all that now. As I've done this, I'm going to save my network information, but while I'm still here, I'm going to look at that surface, which was my roadway. And let's go to my settings and set my contour with 5. So you can see in here, I've got a ditch only where it's let more than 5 feet of fill. So up in here, the ditches aren't needed. Same thing, the berms aren't needed until it's 5 feet high. So it's sort of like putting your guardrails in, and here this ditch would then just spill out into that seam and it would generate that shape. Now, all these weird colors, I'm going to show you now what we have. If we go back to our settings, we go to our output options, and we go to our triangulate and contour setup button. And now we choose set colors and layers. Here's where we can set this. So our edge of pavement, I'm going to process like a gray asphalt. My shoulder, maybe I'll do like a brown. And my ditches, ditch 1 and 2, I'll make those sort of this blue. So 141. And then my berms, I'll make them sort of this green 63. And anything other, we'll just make it a nice, pleasant. Maybe 4, I guess, would be fine. Let's see, try. And then outside, keep like that, maybe. And color style is going to be by grade ID. We'll exit that. We will say okay, yes, okay. And then process. We hit the process button again. And now we're going to look at that roadway surface. And you'll see the colors are now there's my asphalt, my shoulder, my ditches are blue, my berms are that color there.
My settings didn't seem to save. Settings, output, setup, colors. Okay. So you reprocessed the roadway after you changed the color settings, correct?
That is correct, yes.
Okay. And then 3D view surface file viewer. Okay. I don't know what happened last time. For some reason,
May not have been processed or something, I'm not sure.
yeah.
All right, so now you can see, and I've superimposed the other ground onto it so you can see how it ties into
The
the
existing.
existing ground, okay? All right, so now let's do another roadway here, or let me show you what that, if I go to edit that profile, and notice too, as I move this around, you see the marker on this horizontal part of the screen is showing you where that is. Now in the IntelliCAD version, I can zoom this in and out. Apparently I can't do it in AutoCAD.
I can't pan, but I can zoom in and out.
Yeah, I can't do either. It's somehow or another, it's got me stuck inside this. But what I wanted to show you is that if you show the sections, now that we have a template defined,
I see.
and now as you track along here, and let's just do a 220. Great.
It shows you what the road section looks like at any given station along the roadway.
Yep, and up here in the top of the profile, you see it shows you total cut, total fill.
Yep.
So you can see, and it accumulates. So go to the end station, you can see if that's there and whether you want to adjust your profile or not.
Gotcha.
Now I threw an exception. Let's see here. Do I get a chance to get out of it? I don't think so. And I haven't saved anything, but I have the files, so that part's good. Let's see. If I see, I can't exit that. Apparently could exit that. Okay. I can't exit this. I'm now back to that. Let me save. Go out and back in. That's another reason I like the IntelliCAD version better. Okay. Road network, it keeps it the same thing. If I need to change it, I can change files if I want. But now here's my Baker Street. Whoops. Go to Baker Street. Go to my profile. Show my sections. There they are. As I move this along. And then again, what you can see is all of those cut and fill values up there, and it gives you the total.
Yep.
It actually computes the total for the whole thing, but you see it cumulative as you move along. All right. So that's just something that may or may not be of help for you.
Sure.
As you're working. So so now let's put in a crossing street. And I'm just going to draw a simple polyline here. And we'll find C road CL. And let's go from here. I'm just going to eyeball it being perpendicular. I don't really care if it is or not. And then I'll choose add a road by screen pick polyline. I'll choose this one, assign a centerline file, and that other one with Baker Street, this is going to be Seeger Road.
You chose assign centerline file to polyline, correct?
Correct. And then it prompted me for that. There. So now it comes up and it pre-fills all of this stuff out for Seeger Street. I'm going to use the same design template.
Okay. I
could switch it to a different one as long as, and what you have to do is the part that you want to tie into the intersection, in our case, EP, you have to have also a named EP in the other template. Otherwise it gets interrupted. So now for Seeger Road, I'm going to edit the center line and I'm going to put a curve in there. I'll fit my curve. Let's put it 250. Say okay, good, save, exit. Okay, and now do I want to run? I'll say yes. Now watch what happens. You see, it has generated the intersection here. See, it ties the edge of pavement around.
Mm-hmm.
Now, why on earth? Got to look at my output options again. Wow, it didn't store that. 0 minor. Major. Already kept those. Say okay, let's process that again. There we go. Save. Must have been in the mess that I had now. Here is Baker Street. Here's Seeger Road, and here is the intersection. See the target that it showed me when I
Yes.
chose that. It's that little target. Let me
Yep.
get back. I've got what the heck it dropped that in there for, but oh well. All right, so there's my intersection. If I double click the intersection, this is where you can override some of those defaults. So I'm going to tell it which is my primary road. Well, it's Baker Street.
Yep.
In my case, and here's those transitions that I had by default. And here is the template ID that I want to use to transition. If I didn't say edge of pavement and said I only wanted to do the shoulders, then the asphalt would meet at square corners, but the shoulders would go around the curve. So you're going to almost always use that edge of pavement.
So let me ask you, typically, when we were talking about like standard curb return radii, we said 25 is pretty common for
Yeah.
intersections.
Uh-huh.
So at least here, that 25-foot is along the face of curb as opposed to the EP. So
Well, yeah, we don't have any curbs in our template.
okay, yeah, good point.
Yeah, but that would be, the edge of pavement goes up to the face of curb. So that's what it would be there.
So when you're setting, let's say we did have a curbed road section, would when you're setting that like that main default radius for intersections, is I guess is that I guess in terms of it being built into Carlson, is it considering that at the EP? Or so, like, for example, if we did need a 25-foot radius on a curb, then we would have to account for like a 2-foot wide gutter pan. And then we would set the EP radius at 27. Does that, what I said just make sense? I don't know.
Yes. If you chose the EP as the point that it's going to transition, which is what you would want, because you want to push that gutter pan around the curve, right? So now at that point, you're going to want to set that at, if it's the back of curb, so you're going to want that, whatever that curb and gutter distance is, add that to that distance.
Okay.
Yeah, that's exactly right.
Okay.
In fact, let's go ahead and we'll do that. We'll take a look at what this does in their intersection. When we talk about front left, front right, back left, etc., we're talking about if you're on the main road and you're walking down increasing stations.
Yep.
And the front is, all right, I'm going this direction. So my front is the first one I come to, front right, front left, then back right and back left. Okay. So here's where you can change to a different, let's make this one 35, just so you can see what happens to it there when I reprocess it. You're going to see this. Let's make it big enough to see. Apparently I missed.
I think it did the front left Yeah.
Oh, front and left. Okay, yeah. So that would be on the left, not the right. So if I did it even as a 50, you'd see that's a much greater turn there. Okay.
Yep.
So, and again, back in the original settings, we had that
As 25.
25. Now, one thing you can do too on there, let's say I've got this front left, front right. So I'm gonna look at this front right here first. And you see this edit profile? That is of that transition. And so you see as I move this around, and if I wanted to now, I could take this PVI and put a low spot in that transition.
Sorry, 1 second. Could you go back one step, how you got to this menu?
Yes. So I double clicked my intersection. I got this up and I went to the front left. I went to the front right.
Oh, okay. It's under one of the, okay, got it.
Yeah. And so here you can edit the profile. You can edit a template transition, all kinds of things you can do. What different methods? So if you edit that profile, it brings up the profile editor, and you can see as you walk around there, you could just artificially put in, say, a low spot to put an inlet in there.
Yeah.
So I'll do that one. I'll save that and say okay, and then we'll process that again. And now you can see it comes in here, and it's chosen that. We can see it better in our surface viewer. See how we pulled that down?
Mhm.
And these others we didn't adjust. Now we probably really shouldn't have, let's see, front left. I'll leave it as it is without, oops, I think I chose front right was the one I did. Yeah, there. So if let me see, if I choose front right, yeah, I can reset. So it goes back to the default. Process that. Now you'll see the contours are different now. Okay. Now, do we have, let's look at the profiles of Baker Street. I don't have any sag curves. What about Seeger? Now here's where you see it had to go up, and it had to cross. See, I didn't design anything at all. All it did was go up and put in this little vertical curve here, 15-foot vertical curve to transition to the edge of pavement. And that is at a 2.047 because I just eyeballed. I didn't go across perpendicular. If it was perpendicular, it'd be 2%.
Right.
That is a vertical curve of 0 length because it just crowns across. Same thing down to there because that's the edge of that pavement. And then it goes down to this next 15-foot transition and comes back down. Now, what I would do at this point is I would add in, say, a vertical curve here. And let's make that one, say, 100 feet if I can. Yep, that looks good. Maybe add another one down here. 100 feet. Must have missed. Oh, I said 10 instead of 100. There we go. Now, because that's going up and down, let's edit this one so that it's actually in a sag condition. So you see that low spot right there, that purple, that magenta color?
Yes.
So that's a low spot along that road, all right? I'll save this, exit that, I'll say okay, yes to reprocess. Now look what has showed up. See that point? Now, right now it's the center point. So if I go back to my main settings, my output options, down here my output coordinates and choose setup, instead of choosing center, I'm going to choose my shoulder points, let's say. And I would say, ready here, I'm going to come down here and find shoulder. That's the one I want. So shoulder on the left. Shoulder on the right. Let's make sure our center will uncheck. Say, okay, now this also has a little section viewer. So we'll say, okay, say, okay, say, okay, we'll save, we'll process. Now I've got 2 points where I can drop my inlets in. I know what station they are and I know where they're going to be. I know their elevations. So that's the low spot. So if I take look at that in my 3D viewer.
So I think I might have missed something. I tried doing that. It did not generate any.
Any points?
Oh, I don't think I clicked on draw points. That
Okay.
might help.
Yep. So now I've looked at the information. I selected it in my 3D viewer and then added the surface so that I can see right there, see those 2 points right there, they are. And that would be where those inlets would go. Okay. So now I'm just about out of time. Let's edit that.
Did you
want to look at some curves on it, or
I just I pulled up the surface viewer. I was just curious what setting you had checked to display the points on the surface viewer.
I did not use the surface viewer. I used the
the
drawing viewer.
Okay.
I selected those.
Got it.
Yeah. Okay. And then I added the surface on the model tab.
I see. Gotcha.
All right. So now let's go to Baker Street, and we're going to make a new template. We're going to call this one 2-lane with curves. Okay. Yeah, we'll do that. Now, what I'm going to do before I edit that, I'm going to cancel that. I'm going to go to Seeger, 2-lane no curbs. I'm going to edit that one, and I'm going to do a save as. That's what I should have done, what I meant to do. And I'm going to call this one 2-lane with curbs. I'll exit that. We'll go back to Baker Street now, and we'll choose 2-lane with curbs, and we'll edit that. We'll put some curbs in it instead of just the shoulders. So we go to the edge of pavement, and this shoulder, we will remove. And I'm going to say take this stone out as well. And let's say from now the edge of pavement, I'm going to sit there at the edge of pavement. I'm gonna hit my curb. And I'm gonna
So
do,
I think I might have missed something. When I went back into Baker and selected the 2-lane with curbs template, it's empty.
okay, what I did was this. I went into Seeger
Okay.
where it says 2 lanes, no curb. I chose edit and I did a save as.
Okay, gotcha.
That gave me a starting point. That's the only reason I did that.
Got it.
Of course, you're going to wind up having, you know, a whole library of these things once
Yeah.
you're moving along. Okay.
Got it.
So I'm now going to, instead of shoulder, I'm going to take shoulder out. And I'm going to select EP. So I'm at the EP and I'm going to add curbs. And I'll just choose this curb type 1. It's going to be separate from the paving slab. I have a flat base, whatever these dimensions are. And I'm going to call this concrete. And I'll call that one, let's see, you know, and it might be a, you know, an SA6, whatever your standards are, that what have you got curb types. And you got these different types you can choose and set those dimensions. I'll leave that to your own exploration. So there now is that from the curb. I'm going to add another grade at -2% for 2 feet. I'm going to call that SW1. That's going to be where I start my sidewalk. And then I'm going to create another grade of just flat across. I'll call it, I'll go for 6 feet. And I'm going to call that SW2. That's where my sidewalk ends. Okay, so now so far so good. I've got a little buffer spot. It drains off the back of the curb, hits the sidewalk.
Oops.
And then from there, I'm going to add one more grade at -4% for 2 feet and call it edge, just for yucks. So now, here's my sidewalk, starts there, ends, oops, starts there, ends there. There's the width of my sidewalk. So here's what I would do with these subgrades. I would come down here to stone and I would say, I'm going to go to my edge of pavement. Let's see, stone. I'll go to my edge of pavement plus, what did we have? A 2-foot curb structure. Let's say 2.5. And let's do that as a wraparound. And I'm going to go with an 8-inch wrap height. Let's see if that's not what I needed. Okay. Stone wrap height 8 inches.
Oh, you forgot the plus in your distance?
Oh, thank you.
Yep.
There we go. So let's make that, instead of 8 inches, let's make it 10 inches. Let's see what that does for us. Yeah, so there we've got stone around to the back of the curb.
Yep.
You can do it straight up. You can do all kinds of different things with it. Okay.
Mhm.
So then we're going to, actually, I want to tone that down a little bit. Let's make it just a 1.5. That's not enough.
Ooh.
2. There we go. Now, to get to our sidewalk, so that's just grass filter over here, our sidewalk. Now we're going to do another subgrade And this is underneath the sidewalk, and it's also going to be called, no, it's going to be concrete. And it's going to be a horizontal offset now is going to be to SW1. So it's going to go from the center line out to SW1, and it's going to be concrete, and it's going to be, well, we have 6 inches of concrete, and it's going to go to SW2. So there's the concrete, and we'll add one more, oops, not curb, one more subgrade of stone. And it's going to also go to SW1. It's going to go out to SW2. And the vertical offset, we had 6 inches, and we want 8 inches of stone, so that's 14 inches. So there's now my stone and my concrete for my sidewalk. I've got the subgrades under the road. Okay. All right, so we'll save that. We'll exit that. Now, here's what happens when we are intersecting with a road that doesn't have sidewalk and curb. So it comes around here and it goes halfway through the transition and stops. Okay, so those are areas where you might need to, you know, after the fact, do some manual cleanup, tapering or whatever, or maybe you extend it out to a different, yeah, my colors all changed because I changed the template. So you see how that structure came about, and that concrete sidewalk is sort of bluish looking, and they just come out there and they stop, because then we have this little country road that just has ditches and berms and shoulders. Then it comes across, all right? But all I have to do, you know, I can pick these things up and move them around, slide them around, and it will recompute all of those. And again, it enforces the intersection, so it crosses at proper grades and such.
Right.
Okay.
All right.
So with that, there's a lot more that you can do with these. Unfortunately, we just don't have enough time with 2 days to get everything in.
Yeah.
So I would encourage you to.
Sorry, I have a quick question.
Yeah.
Is there a comprehensive class offered?
Well, I mean,
Or do they only break it into civil, break it down by modules, I guess?
it's typically by modules. There's a fundamentals class, but again, it's only 2 days. So it's, you know, you could teach this stuff and you could teach it stem to stern, but I mean, it would take a couple of months, and
Yeah.
people can afford
To go,
that.
yeah, to go through literally every, you know, every
Right.
menu, every button, every functionality. I was just curious if there was anything that compiled like the civil and the hydrology into you know, a single class, so to not a single day, but a
Right,
single
right.
course, so to speak.
Yeah, not so much. We do those on custom for
Okay.
custom training. So like if you go back and everybody's marveling at your great Carlson skills and they want to learn it, and you know, that would be and you got like more than 3 people to get trained,
Yeah.
then that would be where you would want to set up a custom class, and you might, you know, do it, say 3 days, 1 week, wait a month, do 3 days, another week, to sort of reinforce things. And we would really focus on your particular workflow. So
Right.
you did a lot of sewer line, but you didn't do any, you know, you did sanitary sewers, but no storm sewers. And maybe we, you know, give a little shorter shrift on the hydrology, but
Yeah.
other than the sanitary part. But let's say you did not do any road design whatsoever. You're just a grading contractor.
Yeah.
We would focus really tight on what it is that you do.
Okay.
So now let me give you a couple of resources.
Sure.
I'm going to send you, after everything saves and processes, I'm going to send you links to these YouTube videos for these 2 days.
Okay.
And you'll get your certificate of your PDHs for you. Are you a PE?
Yes.
Okay, so you'll get your PEH credit for that. And so we'll send you all of those, that kind of things. And we keep records of all that. So if you happen to lose it, but one thing that we don't do, they no longer allow us to certify these things. We used to be able to, but the state boards all wanted final say. So no, we've never had an issue. We used to be accredited under IASET, the International Association of Continuing Education and Training. And, we submitted all our materials and our processes and they approved it. So it's all good. It's there. But if you're ever audited, because you have to keep track of your records,
Right.
if it's ever audited, then we keep records of your class attendance and all of that.
Okay.
So, and can show the material that they need if they ever need to see it. Now, some resources to help you a little further on the way. Right in the help system itself, let me pull this down here. Carlson Help. Over here on the table of contents, down at the left-hand side toward the bottom, of course, you have each of these things, individual things that you can look up command by command, but there's a set of tutorials.
Yep.
Okay, now you may have seen these already and worked through some of them, and they work with the sample data files that are installed by default when you install the software. Okay,
Yes.
So here's calculating volumes. Now, some of those don't make any real benefits like stockpile volume. So you can do the same thing with the two surface. Here's one using grids. I'm not a big grid person. They're really just not very accurate.
Yeah.
But anyway, road rehab, hydrology and watershed analysis. So this, steps you through all of these different types of things, and they're pretty good. As far as teaching some of the basics, the way the basics goes. But now they have been compiled by sometimes some engineers, sometimes some programmers. Okay, so take those with a grain of salt. The other place to look is these online training movies, also reachable from the help system. And it goes to YouTube, to their channel. And you've got, different things. Here's uploads, Carlson 2020. They're all by different categories, mining, tech tips. You got videos, playlists.
Lasting solely from a.
Oh, good gracious. All right, so videos. And some of them are in foreign languages, so you got to get past that. But here's, Esri maps in the field using CERT PC. Underground mining. So you can find those by, you would just search for civil or what have you. I think they haven't got anything beyond that. You got playlists. Let me see. You got so darn many things that are outside of civil. I wanted to look. Here's civil and hydrology as a playlist. So if I look at that, it's got.
Hello, everyone.
And shut up, Gary. It's Gary Rosen. I know Gary. So up here's power tools, precision 3D, RoadNet, SiteNet, design pad, cross sections. Okay, so there's all of these different things based on that playlist called Civil and Hydrology. And there's several 112 different ones. Okay, so those are all really good. You can see some of them are as short as 2 or 3 minutes. Some of them are half hour, an hour, maybe even. Here's one that's over an hour. Layers and blocks, civil tips and tricks. Okay, and they're done by various people. Some people at Carlson, some of them are done by some outside companies as well. So those are good to have. And also, like I said, if you get into something you want to look at in a little depth at some point later, and you get on a specific with some specific data that we can jump into, I can help you do that. we can do another Zoom session for you. It doesn't take but an hour or two. That's fine. If it were to get into multiple days worth of instruction, then we would talk about, coming up with a custom training
Sure.
type of thing. All right.
All right.
So do those. There's also, if we do SW, I think, let's see here, on the Carlson website, under support and training, that's probably how you found us. Downloads, brochures and documents, movies. And if you go to movies, okay, they've now moved everything over to YouTube.
Okay.
They used to have their own little categories set up and they would store them here. So they finally got everything moved there. So I would focus on looking at, instead of the videos category, I would look at those for sure, but look under the playlists and then check the title of the playlist, because this is not just a single movie. There's 12 videos in this one, 2 in that one. You get the idea.
Yeah.
It's in 2020. There's 8. If I looked at those, I would say,
Welcome to this overview.
shut up. There's the overview, registering a laser scanner. So
I haven't.
some things that don't, some things looks like.
In this
most of
working with
the
design
cinema,
pattern,
there's working multiple pad. That's what we showed you that with the 3 buildings, remember?
Yeah.
And
template video,
so,
we will illustrate how to use multiple polylines to add additional design features to our site. For example, we can quickly add an access ramp to a pad or quickly build a multi-pad environment.
yeah, now,
All right, let's.
one of the things you notice in those 3D viewers, the Carlson folks, for whatever reason, they love to have that color by elevation. And I'm not a fan of that. I like to see the color that, that these things are, so I know what I'm looking at. But anyway, you're probably your choice, but you get an idea, you get some things there that can help you, okay?
Yep.
All righty. Well, like I said, stay in touch with things. I'll send you all that other documentation, and and if you have any questions, pop me an email, give me a call, do whatever you need to do, and I'll help you, through so even if it's something that we covered, you felt like you should have caught and you missed, or if it's something that we haven't even looked at yet, just give me a yell. I'll be glad to help you out. Okay.
All right. I appreciate that, Ken. And thank you very much for the past 2 days. And
Absolutely. Well, you have yourself a lovely weekend. Also, go back into your book and work through those other specific examples. We just sort of did this by rolling up your sleeves and follow the monkey kind of
Yeah.
stuff. Those other things have the step-by-step written out, and you should be able to, when you go through them, you'll recognize things you've already done, and it'll help to reinforce it. Okay.
All right. Thank you very much again, Ken. You have a good weekend.
Sir, you do the same. I'll stop our share. I'll stop the recording.